close your eyes for a moment. Let your eyelids grow heavy, soft, releasing the tension of the day. Take a deep breath. Fill your lungs slowly, feeling the air enter your body cool and refreshing. Hold it there for just a moment, and now release it, letting it flow out naturally, carrying with you any worries, any stress, any thoughts that no longer serve you. Again, breathe in slowly, deeply. Feel your chest rise. Feel the gentle expansion and release. Now, feel the weight of your body against the surface beneath you. Notice how gravity holds you, gently but firmly, connecting you to the earth below. Feel the support beneath your back, your legs, your head. You are held. You are safe. Let your muscles relax one by one, your shoulders releasing downward, your arms growing heavy and peaceful, your legs sinking into rest, your jaw softening, your forehead smooth and calm. In this state of deep relaxation, begin to imagine something extraordinary. Imagine the vastness of space stretching out in every direction, infinite and eternal, not just above you, but all around you, in dimensions your everyday mind struggles to comprehend. Above you, beyond the ceiling of wherever you rest tonight, beyond the clouds that drift through Earth's sky, beyond the blue atmosphere that protects our world, lies an ocean of darkness punctuated by countless points of light. Think about what that means for a moment. An ocean, not of water, but of space itself, emptiness that is somehow full, darkness that contains all light, silence that holds every sound that has ever been or ever will be. This ocean has no shore, no boundary, no end that we can perceive. It stretches on, farther than light itself can travel in the entire age of the universe. Each one of those points of light you see when you look up on a clear night, each star is a sun, a massive ball of nuclear fire, a beacon burning across unimaginable distances. Some of those stars are similar to our own sun, yellow and steady, pouring out warmth and light for billions of years. Others are giants, blue and fierce, burning through their fuel in mere millions of years, living fast and dying spectacularly. Still others are red dwarfs, small and cool, but so long-lived they will burn for trillions of years, long after our own sun has died. And the distances, the distances are almost impossible to truly grasp. The nearest star to our sun, Proxima Centauri, is 4.2 light-years away. That means if you could travel at the speed of light, 299,792 kilometers per second, a speed at which you could circle the entire Earth 7.5 times in a single second, it would still take you over 4 years to reach it, and that is our nearest neighbor. Most of the stars you can see with your naked eye are hundreds or thousands of light years away. Feel the quiet embrace of the stars around you. They do not shout or demand attention. They do not compete for your gaze or insist on being noticed. They simply exist, patiently glowing, waiting to be noticed, waiting to share their secrets. They have been burning for billions of years before you were born, and many will continue burning for billions of years after you are gone. They are ancient witnesses to the unfolding story of the cosmos, silent observers of everything that has ever happened. The night sky above, filled with endless mystery, has watched over humanity since our first ancestors looked up in wonder. Imagine them, those early humans, standing on an African savanna perhaps 200,000 years ago, looking up at the same stars you can see tonight. They did not know what stars were. They could not measure their distances or calculate their masses or understand the nuclear reactions occurring in their cores, but they felt the same wonder you feel now, the same sense of awe at the vastness above them. They told stories about those stars, weaving them into their understanding of the world. They created constellations, seeing patterns in the random distribution of distant suns, a hunter, a bear, a river, They navigated by the stars, planted their crops according to stellar calendars, marked the passage of seasons by which constellations were visible. The stars were their companions, their guides, their gods. And still, after all these millennia, after we have sent spacecraft to other planets and telescopes beyond our atmosphere, after we have learned to measure distances in light years and masses in solar units, after we have discovered that stars are not tiny lights embedded in a celestial sphere, but massive fusion reactors scattered through an incomprehensibly large universe, still, we find ourselves asking the same profound question that must have occurred to those ancient humans. Are we alone? It is a question that resonates through every generation, every culture, every era of human history. Are we the only ones who look up at the night sky and wonder? Are we the only consciousness in all of this vastness? The only minds capable of asking such questions? The only beings who can contemplate the universe itself? We are not alone in the sense that we have each other, here on this pale blue dot spinning through the void, here on this small world, third planet from an average star in the suburbs of an ordinary galaxy. We have company. We have each other, billions of human beings, each one unique, each one containing an entire universe of experience, memory, emotion and thought. We are not alone in our humanity. We have the trees and the oceans, ancient and vast, the lungs and blood of our planet. We have the mountains that rise toward the sky, formed over millions of years by forces we are only beginning to understand. We have the rivers that flow from high places to low, carving the landscape, bringing water and life wherever they go. We have the countless forms of life that share this world with us, the microscopic bacteria, the great whales, the soaring eagles, the humble earthworms, the mighty elephants, the delicate butterflies. Life in all its magnificent diversity surrounds us, accompanies us, sustains us. This planet teems with life. From the deepest ocean trenches where bizarre creatures thrive in darkness and crushing pressure, to the highest mountain peaks where hardy organisms cling to existence in thin air and freezing cold. From the scorching deserts to the frozen tundras, from the steaming rainforests to the windswept grasslands, life has found a way to flourish, to adapt, to persist. We are part of an immense interconnected web of living things, all of us sharing a common ancestor, all of us made of the same basic elements, all of us dancing the same dance of existence. So no, we are not alone on Earth. But beyond our atmosphere, beyond the protective blanket of air that makes our world habitable, beyond our solar system with its 8 planets and countless smaller bodies, beyond our galaxy with its 400 billion stars and their attendant worlds, is there someone else? Something else? Another consciousness? Another spark of awareness gazing back at us across the cosmic expanse? Is there a being on a world circling a distant star, who at this very moment is looking up at their night sky and wondering the same thing? Are they asking if they are alone? Are they searching, as we are searching, for any sign that consciousness has arisen elsewhere? Are they listening to the radio frequencies of space, hoping to hear a signal? Are they dreaming of contact, of communication, of learning they are not the only ones? Or perhaps they have already concluded they are alone, that their universe is empty of other minds, that they are a cosmic accident, a fluke that occurred once and only once in all of space and time. Perhaps they feel the loneliness of that conclusion, the weight of being the only witnesses to existence, or perhaps they have found peace in it, accepting their unique place, their singular responsibility as the universe's only way of knowing itself. This is not just a question of science, though science seeks to answer it. It is not just a matter of radio telescopes and space probes and chemical analysis of distant atmospheres. It is a question of the soul, of our place in existence, of what it means to be alive in a universe so large that it defies comprehension. It touches on our deepest hopes and fears, our sense of meaning and purpose, our understanding of what consciousness is, and why it exists. If we are alone, what does that mean? Does it mean we are special, chosen, the universe's singular experiment in self-awareness? Or does it mean we are terribly cosmically lonely, the only voice crying out in an empty vastness? And if we are not alone, what does that mean? Does it mean we are part of a vast community, a cosmic family of consciousness spread across the stars? Or does it mean we are insignificant, just one among countless others, nothing special or unique? These questions do not have easy answers. They require us to think deeply, to examine our assumptions, to confront the limits of our knowledge and imagination. They ask us to consider possibilities that challenge everything we think we know about our place in the cosmos. Tonight, as you rest here and let your mind drift, as your body relaxes more deeply with each breath, as the concerns of the day fade into the background, we will take a journey together. A journey through time and space, through possibility and wonder, exploring the greatest mystery that has ever captured the human imagination. This is not a journey measured in kilometers or miles, not a physical voyage from one place to another. It is a journey of the mind and spirit, a contemplative exploration of what might be. We will travel back to the beginning, to the birth of stars and the formation of worlds. We will witness, in our imagination, the first light of creation, the moment when the universe came into being. We will watch as gravity pulled together clouds of hydrogen and helium, compressing them until they ignited in nuclear fire. We will see planets forming from the debris of dying stars, rocky worlds coalescing from dust and ice, slowly transforming from chaos into order. We will contemplate what life is, where it comes from, and how it might exist in forms we cannot yet imagine. We will trace the journey from simple atoms to complex molecules, from molecules to cells, from cells to consciousness. We will consider whether this journey is rare or common, whether life emerges easily or only through the most improbable of circumstances. We will listen to the silence of space, that deep, profound quiet that has puzzled us since we first began listening. Is that silence truly empty, devoid of any signal, any message, any indication that we are not alone? Or is it full of sounds we simply do not yet know how to hear? Is it possible that somewhere in some distant corner of the cosmos there is a signal waiting to be heard, a message traveling through space at the speed of light, calling out across the void, hoping for an answer? We will explore the methods we use to search for life, the telescopes that scan the skies, the probes we send to other worlds in our solar system, the calculations and equations we use to estimate the probability of extraterrestrial civilizations. We will consider the paradoxes and puzzles that have emerged from this search. Why, if life is common, have we not yet found any evidence of it? What barriers might prevent civilizations from spreading across the galaxy? What filters might we have passed through, or might still lie ahead of us? And we will turn inward as well, examining what this search tells us about ourselves. What are we really looking for when we scan the skies for alien signals? What void are we trying to fill? What question are we really asking? Perhaps the search for extraterrestrial life is, at its heart, a search for meaning, for context, for an understanding of our own significance in the vast scheme of existence. Let yourself relax into this exploration. Feel your breath, slow and steady. Feel your body, heavy and peaceful. Feel your mind, open and receptive. There is no urgency here, no race to the finish, no deadline to meet. We are simply travelers, you and I, wandering through the landscape of possibility, allowing ourselves to feel the profound sense of awe that comes from confronting the infinite. Time is different here. In this space of contemplation, minutes might feel like hours, or hours like minutes. It does not matter. The universe itself operates on timescales that dwarf our human perception, billions of years passing like moments in the cosmic dance of creation and destruction, transformation and renewal. In this journey, we touch that timeless quality, that eternal present where past and future dissolve into the simple existence of now. The universe is patient. It does not hurry. It does not demand answers immediately. It has been here for 13.8 billion years, and it will continue for perhaps trillions more. No one knows for certain. Stars will burn out, and new ones will ignite. Galaxies will collide and merge, forming new configurations of light and matter. Black holes will swallow entire star systems, and perhaps, in the unimaginably distant future, even they will evaporate into radiation. The universe has seen empires rise and fall, species evolve and go extinct, continents drift and collide, oceans form and disappear. It was here long before humans existed, and it will be here long after we are gone. In the context of such vastness, our brief moment of existence, whether as individuals or as a species, is barely a flicker, and yet in that flicker we can perceive the infinite. We can understand, at least partially, the grand sweep of cosmic history. We can ask questions that span the entire scope of existence. In this moment, right now, we can simply be present with the mystery. We do not need to solve it. We do not need to know the answer definitively. We can rest in the question itself, in the wonder of asking, in the beauty of not knowing. There is something profoundly peaceful about accepting uncertainty, about sitting with a question that may never be answered in our lifetime, perhaps never answered at all. Are we alone in the universe? Perhaps, perhaps not. The truth is, we do not know. Despite all our searching, all our technology, all our theories and calculations, we simply do not know for certain, and there is a strange comfort in that uncertainty, a freedom in admitting the limits of our knowledge. But in searching for the answer, we discover something equally profound. We discover ourselves. We learn what it means to be human, what it means to wonder, to hope, to reach beyond what we know toward what we might know. We discover our capacity for awe, our need for connection, our place in the vast cosmic story that began with the Big Bang and continues through us, through our questions, through our search. So let us begin this journey together, with open minds and wondering hearts, ready to explore the grandest mystery the universe has to offer. Let us ask the questions that matter, even if we cannot answer them. Let us feel the weight and wonder of existence, the strangeness and beauty of being alive in a cosmos that may or may not contain others like us. Breathe deeply. Relax fully and prepare to journey through space and time, through science and philosophy, through facts and speculation, as we explore the profound question, are we alone? Before life, the birth of stars and planets. Long before there was life, long before there were planets or even stars, long before anything we would recognize as the universe we inhabit today, there was light. Not the gentle light of a sunrise painting the sky in shades of pink and gold, not the warm glow of a candle flickering in darkness, not the soft luminescence of the moon reflecting the sun's rays. No, this was light of an entirely different nature, the fierce, brilliant, overwhelming light of creation itself, light so intense it contained within it all the energy that would ever exist. Imagine going back through time, back beyond history and memory, beyond the written word, beyond agriculture and civilization, beyond the first humans who walked upright on the African plains, beyond the first primates, the first mammals, the first animals of any kind, beyond the first complex life forms, the first simple cells, the first stirrings of anything we would call alive, beyond Earth itself, beyond its formation and the cooling of its surface. Go back through the ages of the solar system, past the formation of planets, past the ignition of our sun. Go back beyond our galaxy, beyond the Milky Way's slow spiral of stars and gas and dust, past the formation of the first galaxies, those early congregations of stars that lit up a universe that had been dark for millions of years, past the cosmic dark ages, that period when the universe had cooled enough for atoms to form, but before any stars had ignited, back, back, always back through time, through epochs measured not in years or centuries or even millennia, but in millions and billions of years. Go back 13.8 billion years, to a time when the universe was young and wild and nothing like what we see today, a time when everything was compressed into an infinitesimally small point, smaller than an atom, smaller than anything we can meaningfully measure, a time when the laws of physics as we understand them break down, when our mathematics cannot describe what was happening, when language itself fails to capture the nature of existence. In the beginning, there was the Big Bang, a moment of such profound energy that it defies description, defies comprehension, defies every attempt we make to truly understand it. Not an explosion in space, as the name might suggest, but an explosion of space itself. Space and time coming into existence together, inseparable, two aspects of the same underlying reality we call space-time. In an instant smaller than a heartbeat, shorter than the briefest moment you can imagine, everything that would ever exist came into being. All the matter, all the energy, all the potential for stars and planets and life and consciousness, all of it emerged from that first moment. Space itself unfurled like a flower opening to the sun, expanding at speeds we can barely calculate, doubling and redoubling its size in tiny fractions of a second. And time, that mysterious dimension we all experience but struggle to define, began its slow, steady march forward, from past through present toward future. The universe was hot then, unimaginably hot. Hotter than the core of any star, hotter than any temperature we can achieve in our laboratories, hot enough that matter, as we know it, could not exist. Only energy, pure and undifferentiated, filled all of space. And as the universe expanded, it cooled, gradually, inexorably, temperatures dropping as space itself grew larger. Within the first few minutes, literally, the first few minutes of cosmic history, the universe had cooled enough for the first atomic nuclei to form. Protons and neutrons, the building blocks of atoms, came together in a process called nucleosynthesis. Hydrogen formed first, the simplest element, just a single proton, then helium, with 2 protons and usually 2 neutrons, and traces of lithium, slightly more complex. But that was all. The universe at this early stage consisted of nothing but energy, and these simplest elements, hydrogen, helium, and traces of others. No carbon yet, no oxygen, no iron or gold or any of the heavier elements that make up so much of our world and our bodies. Those would have to wait. Those would require something new, something that had not yet appeared. Stars. But the universe, even in its infancy, even in its simplicity, was not content to remain uniform. Tiny fluctuations in density, quantum variations present from the very beginning, began to have effects. In some regions, matter was slightly more concentrated than in others, and where matter was more concentrated, gravity was stronger. As the universe continued to expand and cool, those regions of slightly higher density began to attract more matter. Slowly at first, imperceptibly, hydrogen and helium atoms drifted toward these gravitational wells. As more matter accumulated, the gravitational pull grew stronger, attracting even more matter in a self-reinforcing process. Those clouds of hydrogen and helium began to gather, drawn together by the invisible hand of gravity, that fundamental force that shapes the universe on the largest scales. Slowly, gently at first, then with increasing momentum over millions of years, these clouds collapsed in on themselves. Picture a vast nebula, a cosmic nursery filled with gas and dust, slowly swirling in the darkness of space. It might span light years across, containing enough material to form thousands or millions of stars. Within this nursery, pockets of material begin to condense, growing denser and denser, forming distinct knots in the cosmic web. As a cloud collapses, The material at its center becomes more and more compressed. The atoms move faster, colliding more frequently, generating heat. The temperature rises. The pressure builds. The center of the cloud becomes a seething, churning mass of hydrogen and helium, growing hotter and denser with each passing millennium. And then, after millions of years of collapse, after the center has become unimaginably hot and dense, something miraculous happens. The pressure at the center builds to a critical threshold. The temperature climbs high enough. Hydrogen nuclei, moving at tremendous speeds, begin to collide with enough energy to overcome the electrical repulsion between them. They fuse together, combining to form helium, releasing energy in the process. Nuclear fusion ignites, like striking a match in a room full of kindling, like lighting a torch in a dark cave. A star blazes to life, pushing back the darkness with its radiant warmth. A new light appears in the cosmos, a beacon that will burn for millions, billions, or even trillions of years depending on the star's mass and type. This is how stars are born, not all at once, not in a single moment, but gradually, through the patient work of gravity, acting over vast timescales. And throughout the early universe, this process repeated itself countless times. Clouds collapsed, centers heated, fusion ignited, and stars lit up the cosmic night. These first stars, the population 3 stars as astronomers call them, were giants, massive and brilliant, perhaps hundreds of times the mass of our sun, shining with the light of millions of suns. They were pure, made only of the primordial hydrogen and helium from the Big Bang, unpolluted by heavier elements because no heavier elements yet existed. And these first stars lived fast. Their enormous mass meant they burned through their hydrogen fuel at prodigious rates. Where our sun will shine for 10 billion years, these first giants lasted only a few million years, a cosmic eye blink, but their brief lives were crucial, essential to everything that would come after. Because these stars died young, and they died spectacularly, in explosions called supernovae that briefly outshone entire galaxies. In their final moments, as their fuel exhausted and their cores collapsed, these stars released more energy than they had emitted during their entire lives. And in those violent deaths, in the unimaginable heat and pressure of a supernova, something new happened. Here is where the magic truly begins. Those dying stars scattered heavier elements throughout space: carbon, oxygen, nitrogen, iron, gold, every element heavier than helium in the periodic table. The intense conditions of the supernova allowed nuclei to fuse into heavier and heavier elements, creating the raw materials for everything that would follow: rocky planets, oceans, life itself, you. We are made of stardust, quite literally. This is not poetry or metaphor, but scientific fact. Every atom in your body, heavier than hydrogen, was forged in the heart of a star that died long before our sun was born. The calcium in your bones was created in a supernova. The iron in your blood, carrying oxygen to your cells, was synthesized in stellar death throes. The carbon that forms the basis of all organic chemistry, the oxygen you breathe, the nitrogen in your DNA, all of it came from stars. When you look up at the night sky, you are not separate from what you see. You are part of it. You are made of the same material, created through the same processes, connected by bonds deeper than you might imagine. Generation after generation of stars lived and died, each one enriching the cosmos with new elements. The universe went through cycles of stellar birth and death, gradually accumulating the chemical complexity necessary for interesting things to happen. The gas clouds from which new stars formed became progressively enriched with heavy elements, allowing for new possibilities. And around these stars, in the swirling disks of leftover material that surrounded them, planets began to form. This material, gas, dust, and the heavier elements created in previous generations of stars orbited the young stars in flat disks. And within those disks, particles began to stick together. Small grains of dust stuck together through static electricity and other forces, growing larger. These larger particles attracted more material through gravity, slowly but inexorably growing. Pebbles became rocks, rocks became boulders, boulders became mountains, and mountains of rock and ice became planetesimals. Objects tens or hundreds of kilometers across, the building blocks of planets. These planetesimals collided with one another, sometimes shattering, sometimes sticking together, gradually building up mass. The process was chaotic, violent, unpredictable, but over millions of years, order emerged from chaos. A few objects grew large enough that their gravity dominated their region of the disk, sweeping up most of the nearby material. Planets formed, worlds born from dust and violence, gradually settling into stable orbits around their parent stars. Some remained close to their stars, heated to extreme temperatures, their light elements boiled away, leaving behind dense cores of rock and metal. Others formed farther out, where it was cool enough for ice to exist, and grew large by accumulating vast atmospheres of hydrogen and helium, becoming gas giants. Our Earth formed this way, approximately 4.5 billion years ago, in orbit around a middle-aged yellow star we call the Sun. It grew from the collision and accretion of countless smaller bodies, gradually accumulating mass until it reached approximately its current size. At first, Earth was a hellish place, molten and violent, bombarded constantly by asteroids and comets. Its surface a churning sea of liquid rock glowing with the heat of formation and radioactive decay. The young Earth had no continents, no oceans, no atmosphere as we know it, just an undifferentiated ball of molten rock, occasionally struck by massive impacts that released enough energy to melt the surface all over again. One such impact, by an object perhaps the size of Mars, likely created our moon, blasting a huge chunk of Earth's material into orbit, where it coalesced into our satellite. But slowly, over millions of years, things changed. The bombardment gradually decreased as the solar system cleared itself of debris. The surface cooled, solidifying into a solid crust. Volcanic activity released gases from the interior, forming an atmosphere, not the oxygen-rich air we breathe, but a reducing atmosphere of methane, ammonia, carbon dioxide, and water vapor. Water arrived, possibly delivered by icy comets from the outer reaches of the solar system, possibly released from the minerals in Earth's interior, or most likely both. As temperatures dropped, this water condensed, falling as rain that lasted for millions of years, gradually filling the low-lying areas of Earth's surface. The first oceans formed, shallow and acidic, nothing like the seas we know today, but water nonetheless. Liquid water, that crucial ingredient. An atmosphere formed. The stage was set for something unprecedented, something that, as far as we know, had never happened before anywhere in the universe, the emergence of life. But Earth was just one world among countless others. Throughout the universe, this same process has repeated itself billions upon billions of times, each iteration slightly different, each producing unique results. Wherever there are stars, there are planets. This is not speculation or hope. We know this now with certainty. Thanks to powerful telescopes, both on Earth and in space, we have detected thousands of worlds orbiting distant suns. We have found rocky planets like Earth, small and dense, hugging close to their stars or orbiting farther out. We have found gas giants like Jupiter, massive worlds with no solid surface, their thick atmospheres hiding whatever lies beneath. We have found worlds of ice, frozen and distant, orbiting at the far reaches of their solar systems. We have found worlds of fire, tidally locked to their stars, one side eternally facing the heat, baked to temperatures where rock vaporizes and rains back down as molten droplets. We have found worlds so strange they challenge our understanding of what a planet can be, super-Earths more massive than our world, but smaller than Neptune, mini-Neptunes with thick atmospheres, but uncertain compositions, worlds that orbit two stars simultaneously. The diversity is staggering, far exceeding what early theorists predicted, and yet, underlying this diversity are common patterns, the same physical laws working themselves out in different circumstances. The universe is creative, but not arbitrary. It explores possibilities within constraints, producing variety without violating the fundamental rules. And so we wonder, among all these worlds, on how many has life emerged? The universe has provided countless stages, countless settings where the drama of existence might unfold. How many of them host actors? How many tell stories of evolution, adaptation, survival, intelligence? We do not yet know, but we keep looking, keep searching, driven by the hope that somewhere among those countless worlds, we might find the answer to our question. Some of these worlds orbit their stars at just the right distance, not too hot, not too cold, but just right for liquid water to exist on their surfaces. We call this the habitable zone, or sometimes, with a touch of whimsy, the Goldilocks zone, and where there is liquid water, there might be life. Think about that for a moment. Right now, as you rest here, there are planets orbiting stars so far away that their light will not reach Earth for millions of years. Some of those planets might have oceans, continents, weather patterns, seasons. Some might be barren and lifeless. But others might be home to something we have only dreamed of. The universe is not a static, empty place. It is dynamic, ever-changing, filled with potential. Stars are being born and dying every moment. Planets are forming, evolving, perhaps even hosting the first stirrings of life. The cosmos is a garden, vast beyond measure, and we are just beginning to explore it. This is the foundation upon which our search for extraterrestrial life rests, not wishful thinking or science fiction fantasy, but the simple, profound reality that the universe is teeming with worlds. The question is not whether other planets exist. We know they do. The question is, has life found a way to emerge on any of them? As you contemplate this, let yourself feel the connection to those ancient stars, the calcium in your bones, the iron in your blood, the oxygen you breathe. All of it was created in stellar furnaces billions of years ago. You are part of this cosmic story, not separate from it. In a very real sense, the universe is not something you observe from the outside. You are the universe observing itself, pondering its own mysteries, searching for its own meaning. And somewhere out there, on a planet circling a distant star, perhaps another consciousness is doing the same thing, looking up at their night sky and wondering if they are alone. What is life? From the first spark to complexity. What is life? It seems like such a simple question, one we should be able to answer easily. After all, we know life when we see it. A bird singing in a tree is alive. A flower opening to the sun is alive. You, reading these words, are alive. But defining life precisely, in a way that encompasses all its forms and distinguishes it from non-life, is surprisingly difficult. At its most basic level, life is a process, not a thing. It is the ability of a system to maintain itself, to take in energy from its environment and use that energy to grow, reproduce, and respond to changes. Life fights against entropy, the natural tendency of the universe to drift toward disorder. While everything else in the cosmos gradually breaks down and scatters, life builds up, organizes, creates complexity from simplicity. But let us go back to the beginning, to that moment when non-life became life. On the young Earth, approximately 4 billion years ago, the conditions were right for something extraordinary. The planet had cooled enough to have solid ground and liquid water. The atmosphere was thick with gases, methane, ammonia, water vapor, but very little oxygen. Lightning crackled through the skies. Volcanoes spewed molten rock and ash. It was a harsh world, but it was also a world of possibility. In the oceans, or perhaps in shallow tidal pools, or near volcanic vents deep beneath the waves, simple molecules began to interact. Carbon atoms, the building blocks of life as we know it, have a remarkable ability to form long, complex chains and rings. Combined with hydrogen, oxygen, nitrogen, and other elements, these carbon molecules created organic compounds, amino acids, sugars, the precursors to life. Imagine it like this: a primordial soup, rich with chemical ingredients, stirred by the energy of lightning and volcanic heat. Gradually, through countless random interactions, these molecules found ways to stick together, to form patterns. Some of these patterns were better at persisting than others. Some could make copies of themselves, using the surrounding molecules as raw materials. This was not yet life, not as we would recognize it, but it was the first step, the first whisper of something new emerging from the cosmic silence. These self-replicating molecules were like echoes of a song, repeating and varying, each generation slightly different from the last. Over millions of years, these molecular systems grew more sophisticated. Membranes formed, creating boundaries between inside and outside, defining a self. Proteins emerged, capable of performing specific tasks. And most crucially, DNA and RNA developed, molecules that could store information, instructions for building and maintaining the system. The first true cells appeared, simple single-celled organisms without even a nucleus, but alive nonetheless. Life had emerged, not through magic or divine intervention, though there is something magical about it nonetheless, but through the patient, relentless creativity of chemistry and time. The universe had learned to organize matter in a way that could persist, grow, and evolve. And then, life did something even more remarkable. It diversified. For billions of years, Earth was a planet of microbes, but these simple organisms were constantly evolving, adapting to different environments, developing new strategies for survival. Some learned to harvest energy from sunlight through photosynthesis, releasing oxygen as a waste product. This oxygen gradually accumulated in the atmosphere, transforming Earth's environment and opening up new possibilities. Eventually, cells learned to cooperate, forming multicellular organisms. Complexity built upon complexity. Specialized tissues emerged, some cells dedicated to sensing the environment, others to movement, others to digestion. Life colonized every available niche, from the deepest ocean trenches to the highest mountain peaks, from scorching deserts to frozen tundras. The journey from those first simple cells to the vast diversity of life we see today took billions of years. It was not a straight path or a guided process, but rather a wandering exploration of what was possible. Evolution through natural selection acted like a sculptor, slowly shaping and reshaping the clay of living matter, eliminating what did not work and building on what did. And here we are now, the products of that unimaginably long journey. We are complex assemblages of trillions of cells, each one a descendant of those first primitive organisms. We have nervous systems capable of processing information, brains capable of contemplating the universe itself, consciousness capable of asking why. But here is the truly profound question. If life emerged on Earth through natural processes, following the laws of chemistry and physics, could it not emerge elsewhere? The same elements that make up our bodies exist throughout the universe. The same laws of nature apply everywhere. Water, that crucial ingredient for life as we know it, is common on many worlds. What if there are other sparks of life, just like ours, somewhere out there? What if, on a planet orbiting a red dwarf star in a galaxy far from our own, simple molecules are right now beginning to organize themselves, taking their first tentative steps toward complexity? What if, On a world with conditions vastly different from Earth, life has found entirely different solutions to the problem of existence, using different chemistry, different structures, different strategies. Life might not be rare at all. It might be woven into the very fabric of the cosmos, an inevitable consequence of chemistry given enough time and the right conditions. Or perhaps life is exceedingly rare, a lucky accident that occurred only once, or a handful of times in the entire history of the universe. We do not yet know. But the existence of life on Earth proves one crucial thing. It is possible. Life can emerge from non-life. Consciousness can arise from matter. The universe can become aware of itself. And if it happened here, on this small planet orbiting an average star in the suburbs of an ordinary galaxy, why not elsewhere? As you think about this, consider your own existence. You are made of atoms that were once scattered across space, that came together through gravity to form a star, were cooked in that star's core, were scattered again when the star died, and eventually found their way into your body. You are billions of years old, in a sense made of recycled stardust, and you are also brand new, a unique configuration of matter that has never existed before and will never exist again. Life is both ordinary and miraculous. It follows natural laws, yet produces outcomes of staggering beauty and complexity. And if life exists elsewhere in the universe, it too would be both ordinary and miraculous, different from us in details perhaps, but sharing the same fundamental property, the ability to persist, to grow, to reach toward the future. The quest for extraterrestrial life, searching the cosmos. For most of human history, the question of life beyond Earth was purely philosophical. We could wonder, speculate, imagine, but we had no way to actually search for answers. The stars were unreachable, mysterious lights in the sky whose true nature we could only guess at. But in the last century, everything changed. We developed the tools to begin answering the question scientifically. The search for extraterrestrial life is not a single project or program. It is a constellation of efforts, each approaching the question from a different angle, each contributing pieces to a grand puzzle. Some scientists focus on our own solar system, searching for signs of life on nearby worlds. Others cast their nets wider, looking for habitable planets around distant stars. Still others listen to the radio frequencies of space, hoping to catch a signal from an alien civilization. Let us start close to home. Mars, our planetary neighbor, has long been a focus of our curiosity. It is a cold desert world now, with a thin atmosphere and no liquid water on its surface. But it was not always so. Billions of years ago, Mars was warmer and wetter, with rivers flowing into vast lakes and perhaps even seas. If life emerged on Earth during its wet phase, could it not have emerged on Mars as well? We have sent rovers to Mars, robotic explorers that trundle across the rusty sand, analyzing rocks and soil, searching for organic molecules or other signs that life once existed there. Perhaps it still does, hidden beneath the surface where conditions might be more favorable. Microbial life, tough and resilient, clinging to existence in underground aquifers or sheltered pockets. We send our machines as ambassadors, patient and tireless, sifting through the Martian dirt for clues. Then there are the moons of the outer solar system. Europa, orbiting Jupiter, is covered in ice, but beneath that frozen shell lies an ocean of liquid water, kept warm by tidal forces as Jupiter's gravity flexes and squeezes the moon's interior. Could life exist in that dark ocean, never seeing the sun, drawing energy from chemical reactions near hydrothermal vents? On Earth, we find life in similar environments, thriving in the deep sea where no light penetrates. Enceladus, a small moon of Saturn, also has an underground ocean, and it actively sprays water and organic molecules into space through cracks in its icy surface. Titan, Saturn's largest moon, has lakes and rivers not of water, but of liquid methane and ethane. Could life use these exotic liquids instead of water? Could it be based on different chemistry entirely? These are not idle questions. NASA and other space agencies are planning missions to explore these worlds more thoroughly, to drill through the ice, to swim in alien oceans, to search for any sign of life. The answers might come in our lifetime, or they might take generations, but we are looking, we are searching. Beyond our solar system, the hunt takes on a different character. We cannot visit these distant worlds, at least not yet. The nearest star is over 4 light-years away, and with our current technology, it would take tens of thousands of years to reach it. But we can observe these worlds from afar, using increasingly sophisticated techniques. When a planet passes in front of its star from our perspective, it blocks a tiny fraction of the star's light. By carefully measuring this dimming, we can determine the planet's size and orbital period. By analyzing how the starlight filters through the planet's atmosphere, if it has one, we can detect the chemical signatures of different gases. Oxygen, methane, carbon dioxide, each leaves a distinct fingerprint in the spectrum of light. This is how we search for biosignatures, signs that life might be present on a distant world. Oxygen in large quantities might indicate photosynthetic life as it does on Earth. Methane combined with oxygen could suggest biological processes, since these gases react and destroy each other unless something is constantly replenishing them. It is detective work on a cosmic scale, piecing together evidence from light that has traveled for years or decades to reach us. We have found thousands of exoplanets now, planets orbiting other stars. Some are gas giants, others are rocky worlds. Some orbit so close to their stars that their surfaces are molten. Others are frozen, far from any warmth, but scattered among them are planets in the habitable zone, worlds where liquid water could potentially exist. These are the prime candidates in our search, the places where life, as we understand it, might have a chance. Picture a planet, similar in size to Earth, orbiting a star not too different from our Sun. It has an atmosphere, continents, oceans, clouds drift across its sky. Seasons change as it tilts on its axis. Is there life there? We do not know. We cannot see individual features on its surface. It is far too distant for that. But we can measure, we can analyze, we can infer, and one day perhaps we will detect something, a chemical signature that has no explanation other than life. The search is slow. It requires patience, dedication, and an acceptance that we might not find answers in our lifetime. But it also requires hope, a belief that the search itself is worthwhile, that the question matters even if the answer eludes us. Every telescope we build, every space probe we launch, every data set we analyze brings us incrementally closer to understanding our place in the cosmos. We send our messages into the void, hoping that somewhere, someone or something is listening, not desperate calls for help, but greetings, introductions, invitations to communicate. The famous golden records aboard the Voyager spacecraft contain sounds and images from Earth, music, greetings in different languages, pictures of humans and animals and landscapes. They are time capsules, but also messages in bottles, cast into the cosmic ocean with the hope that someday someone will find them. There is something poignant about this search. We are a young species, barely out of our infancy in cosmic terms. We have only recently developed the technology to even begin looking beyond our own world, and yet we look with such earnestness, such hope. The search for extraterrestrial life is not just about finding aliens. It is about understanding life itself, about placing our own existence in context, about answering the fundamental question, are we alone? The universe is vast. It contains hundreds of billions of galaxies, each containing hundreds of billions of stars, many with planets of their own. The numbers are so large they lose meaning, but somewhere in all that vastness, there might be another world where another consciousness has looked up at their sky and wondered the same thing we wonder. And that possibility, however remote, however uncertain, fills us with a sense of connection that transcends distance and time. We keep searching, not because we are certain we will find something, but because we must. It is part of what makes us human, this drive to explore, to question, to reach beyond what we know into the realm of what might be. And in searching for life elsewhere, we discover more about our own world, our own life, our own capacity for wonder. The Drake equation? The possibility of other life. Sometimes, when we confront a question too vast to grasp directly, we break it down into smaller pieces. This is what Dr. Frank Drake did in 1961, when he formulated what has become known as the Drake equation. It is not really an equation in the sense of producing a definitive answer. Rather, it is a framework for thinking about the probability of intelligent, communicative life in our galaxy. Imagine you are trying to estimate how many needles might be in a very large haystack. You cannot search every piece of hay, so instead you ask, how big is the haystack? How often do needles appear in haystacks generally? How long do needles typically remain findable? By breaking the problem into components, even if you do not know the exact answers, you can begin to estimate the range of possibilities. The Drake equation works the same way. It asks how many civilizations capable of communication might exist in the Milky Way galaxy right now, and it breaks this enormous question into manageable parts, each addressing a different factor that contributes to the answer. First, consider the rate at which stars form in our galaxy. Stars are the necessary first step. Without them, there are no planets. And without planets, there is nowhere for life to develop. Our galaxy produces several new stars each year, on average. Some years more, some years less, but over long time scales, there is a steady production of new stellar systems. Next, what fraction of those stars have planets? When Drake first formulated his equation, we did not know the answer to this question. Planets were theoretical possibilities around other stars, undetected and unconfirmed. Now, thanks to decades of observation, we know that planets are common. Most stars have them. The fraction is high, perhaps even approaching 1. Of the stars with planets, how many have planets in the habitable zone? This fraction is smaller, but still significant. Not every planetary system has a world at the right distance from its star, but many do. We have found hundreds of potentially habitable planets already, and we have only surveyed a tiny fraction of the galaxy. Here is where the equation enters more speculative territory. On what fraction of these habitable planets does life actually emerge? We have a sample size of 1, Earth, where we know life appeared relatively quickly after conditions became favorable. Does this mean life emerges easily, given the right conditions? Or was Earth an extraordinary stroke of luck? We do not yet know. Some scientists think life might be common, arising naturally from chemistry, wherever conditions permit. Others think it might be vanishingly rare, requiring such an unlikely sequence of events that it happens only once in billions of worlds. Even if life emerges, on what fraction of those worlds does it evolve intelligence? Intelligence, as we define it, is quite recent on Earth. Life existed for billions of years before creatures with complex brains and problem-solving abilities evolved. Is intelligence an inevitable outcome of evolution, something that emerges reliably given enough time, or is it a quirk, a lucky accident, one path among countless others that evolution might take? And if intelligence does evolve, does it develop technology capable of communication across interstellar distances? Again, we have only one example, ourselves. We have had radio technology for barely over a century. Other intelligent species on Earth, dolphins, elephants, crows, do not build telescopes or transmit radio signals. Is technological development inevitable for intelligent species, or are we unusual in this regard? Finally, how long do such civilizations last? This might be the most uncertain factor of all. We have only been capable of radio communication for about 100 years out of the billions of years Earth has existed. If civilizations typically last only a short time before destroying themselves or losing interest in communication, then even if many arise, few might exist simultaneously. The galaxy could be teeming with life, but spread across such vast spans of time that civilizations rise and fall without ever overlapping. It is like a cosmic guessing game, a puzzle where we do not yet know all the pieces, but we keep searching for answers. The Drake equation does not give us a definitive number. Depending on the values you assign to each factor, and those values can range by many orders of magnitude, you can get answers ranging from "we are alone" to "there are millions of civilizations in our galaxy right now." But the value of the equation is not in producing an answer. It is in providing a framework for thinking systematically about the question. It highlights where our knowledge is strong and where it is weak. It shows us which factors we need to investigate further. And it reminds us that the question is not just about aliens. It is about understanding life, intelligence, and civilization in all their forms. Some scientists plug in optimistic values and conclude that the galaxy must be full of life. Others use conservative estimates and suggest we might be alone, or nearly so. The truth likely lies somewhere in between, but where exactly we can only guess. There is something beautifully humble about this equation. It acknowledges our ignorance while also providing a path forward. We do not know the answer, it says, but here are the things we need to figure out. It is an invitation to research, to discovery, to patient, methodical exploration of the cosmos and our place within it. As you think about this equation, consider what your own intuition tells you. Do you think life is common, scattered abundantly across the universe? Or do you think it is rare that we might be one of only a handful of living worlds? There is no right answer yet, no way to know for certain. But in pondering the question, you engage with one of the deepest mysteries we face. The equation also reminds us of how young we are, how new to this cosmic stage. We have only just begun to develop the tools to explore these questions scientifically. 100 years ago, we did not even know that other galaxies existed. 50 years ago, we had not yet found a single planet outside our solar system. Who knows what we will discover in the next 100 years, or the next 1,000? The Drake equation is not a formula for calculating loneliness or companionship in the cosmos. It is a meditation on probability, a way of organizing our uncertainty, a reminder that the universe holds secrets we have barely begun to uncover. And in that uncertainty lies both anxiety and hope, the possibility that we might be unique, and the possibility that we might be part of something much larger than ourselves. Are we alone? The silence of the universe. There is a profound silence in the universe, a quietness so deep and so complete that it sometimes feels like a presence in itself. We have been listening now for decades, our radio telescopes tuned to the frequencies of space, searching for any signal that might indicate intelligence, any pattern that could not be explained by natural processes. And yet, the universe remains silent. This silence is puzzling, given the vast number of stars and planets, given the apparent ease with which life arose on Earth, given the billions of years available for civilizations to develop. We might expect the galaxy to be buzzing with activity. We might expect to see evidence of alien engineering, to intercept their communications, to detect their presence in 1,000 different ways. And yet, we see nothing, we hear nothing. The cosmos is quiet. This is sometimes called the Great Silence, or, more formally, the Fermi paradox, after physicist Enrico Fermi, who famously asked, "Where is everybody? If intelligent life is common, if civilizations have had billions of years to spread across the galaxy, why have we not encountered them? Why are they not here?" Perhaps the silence means we are alone, or nearly so. Perhaps life, despite appearing easily on Earth, is actually extraordinarily rare. Perhaps intelligence is even rarer still. Perhaps we are the first or among the first civilizations to arise in our galaxy. If so, the cosmos is ours to explore, ours to fill with our presence and our questions. But this possibility carries with it a profound loneliness, a weight of responsibility. If we are the only ones, then the universe's capacity to understand itself rests solely with us. Or perhaps we are not alone, but civilizations are spread so thinly across space and time that we simply have not encountered them yet. The galaxy is unimaginably vast. Even traveling at the speed of light, it would take 100,000 years to cross from one side to the other, and we cannot travel at the speed of light. Physical distances might simply be too great for civilizations to meet, communicate, or even know of each other's existence. Time presents another barrier. Civilizations might rise and fall, separated by millions or billions of years. Perhaps there have been countless others before us, and there will be countless others after us. But we exist in different epochs, our lights flickering in the darkness at different moments, never overlapping. The galaxy might be full of ruins, the echoes of vanished civilizations, but by the time we find them, they will have been silent for eons. There is also the possibility that we are not recognizing the signals. We search for radio transmissions because that is what we would send, but an alien civilization might communicate in ways we have not imagined, using technologies we do not understand. Their signals might be all around us, and we simply do not recognize them as artificial because we are looking for the wrong thing. Or perhaps advanced civilizations deliberately choose silence. If the universe is dangerous, if announcing your presence risks attracting hostile attention, then the wise choice might be to remain quiet, to observe without revealing yourself. This is sometimes called the dark forest hypothesis, the idea that the universe is full of civilizations, all hiding from each other, afraid to break the silence. Another explanation is that civilizations might commonly destroy themselves shortly after developing advanced technology. We know this is possible. We have come perilously close ourselves with nuclear weapons and environmental degradation. Perhaps the transition from a planetary species to a spacefaring civilization is so difficult, so fraught with existential risks, that most societies fail to make it. The galaxy might be littered with the remnants of civilizations that almost made it, but did not quite survive their own technological adolescence. Or maybe intelligence does not inevitably lead to curiosity about space. We assume that any intelligent species would want to explore, communicate, and expand because that is what we want. But perhaps other forms of intelligence have different values, different priorities. Perhaps they turn inward rather than outward, developing rich virtual realities or contemplative philosophies rather than radio telescopes and spacey ships. They might exist, thriving on their worlds, but with no interest in reaching out to the stars. The silence could also be temporary. Perhaps civilizations go through phases of expansion and communication, followed by long periods of consolidation or isolation. We might be listening during a quiet period, a cosmic intermission between acts, or we might simply not have been listening long enough. On the timescale of the galaxy, we have been listening for the blink of an eye. It would be like expecting to see a shooting star by glancing at the sky for 1 second, possible, but unlikely. There is something haunting about this silence, something that stirs both fear and wonder. It reminds us of how small we are, how precarious our existence might be, but it also invites contemplation of deeper questions. What does it mean to be alone? What does it mean to have company? Are we seeking objective answers, or are we seeking something more intangible, connection, recognition, proof that consciousness is not an isolated accident, but a fundamental feature of the universe? Maybe we are not alone. Maybe we are simply waiting for the right moment to listen, or the right place to look, or the right question to ask. The universe is patient. It does not rush to reveal its secrets. It has been here for nearly 14 billion years, and it will be here long after we are gone. In the context of such vastness, our brief moment of listening is barely perceptible. Consider the possibility that somewhere on a world orbiting a star we cannot even see, another being is pondering the same silence. They too have built telescopes, searched their skies, listened to the radio frequencies of space. They too have heard nothing. Perhaps they are concluding that they are alone, that their universe is empty of other minds, and yet, unknowingly, we exist. They exist. The universe is not empty after all. We have simply not yet found each other. The silence might break tomorrow, or 1,000 years from now, or never. We do not know. But in the meantime, we continue listening, we continue searching, because even if the silence persists, the search itself transforms us. It makes us more thoughtful, more humble, more aware of how extraordinary our own existence is. And perhaps the lesson of the silence is not about them, but about us. Perhaps it is teaching us to value what we have, here on this small world, the precious and fragile gift of life and consciousness, the community we share with each other and with all living things on earth. Perhaps before we can find others, we need to fully appreciate ourselves. The silence is not empty. It is full of possibility, pregnant with potential. Every moment that we do not hear a signal is a moment that maintains the mystery, keeps the question alive, allows us to continue wondering and hoping. And maybe that wondering, that hoping, that reaching toward the unknown is itself a form of connection, a way of participating in the great cosmic conversation, even if we do not yet know who else is listening. Signs of life. The search for alien signals. In the high deserts of California, massive radio dishes point toward the sky, slowly tracking across the heavens as Earth rotates. These are not looking at visible light, but at longer wavelengths, radio waves that can travel vast distances through space without being absorbed or scattered. And they are listening, patiently, methodically, scanning the sky for any signal that might indicate intelligent origin. This is SETI, the search for extraterrestrial intelligence. It is based on a simple but profound idea. If advanced civilizations exist elsewhere in the galaxy, they might be using radio waves to communicate, just as we do. And if they are transmitting signals, whether deliberately aimed at other stars or just leaking into space as a byproduct of their technology, we might be able to detect them. Every signal we hear could be the voice of a distant world, speaking to us across the cosmos. Imagine that you are sitting in a control room, watching data flow across computer screens, when suddenly there is a pattern, a regularity that cannot be explained by any natural phenomenon. A sequence of pulses perhaps, or a modulated signal carrying information. In that moment, everything would change. We would know with absolute certainty that we are not alone. It has not happened yet. Over the decades of searching, we have detected many interesting signals, anomalies that briefly raised hopes before being explained as interference from satellites, glitches in equipment, or rare but natural astronomical phenomena. The most famous was the WOW signal detected in 1977, a strong narrowband radio signal that lasted 72 seconds and appeared to come from the direction of the constellation Sagittarius. It matched all the characteristics of an artificial signal, but it was never detected again. To this day, we do not know what it was. The search continues. Modern SETI projects analyze millions of radio frequencies simultaneously, using sophisticated algorithms to filter out noise and identify patterns that might indicate intelligence. They look for signals that are narrowband, concentrated at specific frequencies which does not occur naturally. They look for signals that change in ways that suggest deliberate modulation, encoding information the way our own transmissions do. But radio waves are just one approach. Some researchers search for optical signals, brief, powerful pulses of laser light that could be used for communication across interstellar distances. Others look for more exotic signatures, unusual infrared emissions that might indicate mega-engineering projects, or anomalies in how light travels through certain regions of space that might hint at advanced technology. There is something beautifully patient about this work. It requires faith in the long term, an acceptance that the answer might not come in our lifetime, but that the search is worthwhile regardless. The scientists and volunteers who dedicate themselves to SETI are engaged in one of humanity's most profound endeavors, not for personal glory or immediate reward, but for the simple, powerful reason that the question matters. Think about what it means to listen to the universe in this way. We are eavesdropping on the cosmos, attentive to every whisper, every flutter of electromagnetic radiation. Most of what we hear is natural: the hiss of hydrogen gas between the stars, the pulse of rotating neutron stars, the roar of distant galaxies. The universe is not actually silent. It is full of sound, or rather full of electromagnetic signals that we can translate into sound. But it is natural sound, the voice of physics and chemistry, not the voice of mind. What would an alien signal sound like? We cannot know for sure. It might be a simple repeating pattern, like a cosmic lighthouse announcing its presence. It might be complex, encoding vast amounts of information in every burst. It might be subtle, buried in what appears to be natural noise until you know exactly where and how to look. Or it might be obvious, a bright beacon, intentionally designed to be found by anyone capable of listening. Some scientists argue that advanced civilizations would not use radio at all, that it is primitive technology we use only because we are still in our infancy. By the time a civilization is truly advanced, they might communicate through quantum entanglement or manipulate space-time directly, or use methods we cannot even conceive of. If so, our radio searches might be futile, like trying to find a text message by listening to telegraphs. But others point out that radio waves are efficient, capable of carrying large amounts of information across vast distances with minimal energy. Even an advanced civilization might use them, at least for initial contact or for broadcasts meant to be detectable by emerging species like ourselves. The physics of the universe does not change with advancement. Radio waves remain radio waves, useful tools in any technological toolbox. There is also the possibility that we have already received signals but failed to recognize them. Our equipment might not have been sensitive enough or pointed in the right direction at the right time. Space is vast, and signals degrade as they travel, spreading out and weakening until they are barely distinguishable from background noise. A transmission that was clear and strong on its home world might arrive here as a faint whisper, detectable only with the most powerful equipment and careful analysis. The search for alien signals is not just about technology, it is about philosophy and hope. It reflects our deep-seated need to connect, to communicate, to share our existence with others. We are social beings, and the thought that we might be utterly alone in the universe is for many almost unbearable. So we listen, not just with our ears but with our hearts, hoping that somewhere out there, someone is speaking. And even if we never hear anything, the act of listening changes us. It makes us more aware of our place in the cosmos, more thoughtful about what it means to be a communicating species. It inspires new technologies, drives scientific innovation, and brings together people from around the world in a shared pursuit. There is a beauty in the search itself, independent of whether it succeeds. It is an expression of our curiosity, our courage, our refusal to accept that the universe is indifferent to our existence. Every hour spent listening is an hour spent reaching beyond ourselves, affirming that the question matters even if the answer remains elusive. So the telescopes point upward, the computers process data, and the search continues. Maybe tomorrow, or next year, or in a century, we will hear something. Or maybe we never will. But in the meantime, we listen, we pay attention. We remain open to the possibility that somewhere in the vast darkness there is another voice, and that someday, somehow, we will hear it calling out to us across the light years, saying, "We are here. You are not alone." The possibility of alien life, microbial life to complex beings. When we imagine alien life, our minds often conjure dramatic images: tentacled creatures emerging from spaceships, humanoid beings with large eyes and advanced technology, vast civilizations spanning multiple star systems. But the truth is, if we encounter extraterrestrial life, it will most likely be far less dramatic, at least at first. The vast majority of life on Earth consists of microorganisms, bacteria, archaea, single-celled creatures too small to see without a microscope. These tiny beings outnumber all other forms of life by staggering margins. They exist everywhere, in soil, in water, in the air, even deep within rock miles beneath the surface. They thrive in conditions we would consider extreme: near boiling hot springs, frozen Antarctic lakes, acidic pools, radioactive waste. They are in many ways the most successful form of life our planet has produced. If life exists elsewhere in the universe, it might well take similar forms, not identical of course. Evolution on another world would follow different paths, produce different solutions to the challenges of existence, but the basic principles might be the same: small, simple, adaptable organisms, capable of surviving in harsh conditions, slowly evolving over billions of years. What if life is not green and human-like, but small and quiet, hidden in the shadows of distant worlds? What if the first extraterrestrial life we discover is not a civilization but a microbe, living in the subsurface ocean of Europa or clinging to life in the permafrost of Mars? There would be no greeting, no exchange of ideas, no dramatic first contact, just a quiet confirmation, perhaps through chemical analysis or microscopy, that somewhere beyond Earth, life has independently emerged. And yet that discovery would be momentous. It would answer one of humanity's deepest questions. Are we alone? Finding even simple microbial life elsewhere would have profound implications. It would suggest that life is not a unique accident, but a natural outcome of chemistry under the right conditions. If life emerged independently on two worlds in the same solar system, then the universe must be teeming with it. Countless planets, countless microbes, countless experiments in what is possible. But life might not stop at the microbial stage. On Earth, single-celled organisms eventually evolved into multicellular forms. First simple colonies, then more complex organisms with specialized tissues, and eventually the staggering diversity of plants, animals, and fungi we see today. The transition from single cells to multicellularity is not easy. It required several billion years on Earth, but it happened, which means it is possible. Could the same transition occur elsewhere? Could alien microbes, given enough time and the right conditions, evolve into more complex forms? Imagine alien forests, alien oceans teeming with life, ecosystems as rich and varied as our own, but built from entirely different starting materials. On Earth, all life shares a common ancestor and uses the same basic biochemistry: DNA, RNA, proteins, cells with similar structures. But alien life might be radically different. It might use different molecules to store information, different chemical reactions to generate energy. It might not even be carbon-based. Silicon, with similar bonding properties to carbon, is sometimes suggested as an alternative, though it presents challenges carbon does not face. Think about a world orbiting a red dwarf star, smaller and cooler than our Sun. Such stars are the most common in the galaxy, and many of them have planets in their habitable zones, but life on such a world would face different conditions than life on Earth. Red dwarfs emit most of their light in infrared wavelengths, so plants, if there are plants, might be black instead of green, absorbing every available photon. The planet might be tidally locked, always showing the same face to its star, with permanent day on one side and permanent night on the other. Life there would adapt to these conditions in ways we can barely imagine. Or consider a world with higher gravity, where everything is shorter and sturdier, or a world with lower gravity, where creatures might grow tall and delicate. A world with a thicker atmosphere might support flying creatures the size of elephants. A world with less oxygen might never develop large energetic animals at all. The possibilities are endless, constrained only by the laws of physics and chemistry, and those laws are the same everywhere, but they allow for such incredible variation that no two worlds would host identical life. Evolution is creative, opportunistic, finding solutions to problems in whatever way works. The specific forms it produces depend on local conditions, the available energy sources, the chemical composition of the environment, the presence or absence of water, the intensity and type of radiation from the star. Intelligence, if it evolves at all, might take forms we do not recognize. We think of intelligence in terms of problem solving, tool use, complex communication, the traits that define human intelligence. But other forms of intelligence might exist: distributed intelligence in colony organisms, slow but deep intelligence in long-lived beings, purely instinctual intelligence that operates without conscious thought. We must be careful not to assume that alien life, even intelligent alien life, would resemble us in any meaningful way. Evolution has no goal, no destination. It does not strive toward intelligence or complexity. It simply favors whatever traits help organisms survive and reproduce in their environment. On another world, those traits might be entirely different from the ones that led to humans. There is humility in acknowledging this. We are not the template for all life, not the pinnacle toward which evolution inevitably moves. We are one solution among countless possibilities, one path that happened to be taken on one small world. Alien life, in all its forms, would remind us of this, that life is diverse, creative, and far stranger than we can imagine from our limited perspective. So when we search for life, we must keep our minds open. Yes, we look for Earth-like planets with liquid water and oxygen-rich atmospheres, because that is what we understand, what we know works. But we must also be ready for surprises, for forms of life that challenge our assumptions and expand our understanding of what is possible. Maybe life is everywhere, in forms so small and strange we would overlook them if we were not paying attention. Maybe it is hiding in plain sight in places we have not thought to look. Maybe it is waiting for us to become wise enough, humble enough to recognize it for what it is. And maybe, just maybe, somewhere among all those microbes and simple organisms, intelligence has emerged again, different from ours but real nonetheless. Minds that ponder the same questions we ponder, hearts that feel the same wonder we feel when gazing at the stars. We do not know, but the possibility fills us with hope and keeps us searching. The limits of imagination. What could alien life look like? Close your eyes and try to picture an alien. What do you see? Most likely, your imagination conjures something vaguely humanoid. 2 arms, 2 legs, a head, eyes. Perhaps the proportions are different. The skin, a strange color, the features unusual, but the basic body plan is familiar, recognizable, something your mind can grasp. This is natural. We imagine based on what we know, and what we know is life on Earth, specifically ourselves. But here is the profound truth. Alien life, if it exists, might be so different from anything we have encountered that our imagination fails completely when trying to picture it. Evolution on Earth has produced an astonishing variety of forms, from microscopic bacteria to blue whales, from jellyfish to trees, from fungi to birds. And yet, all of this diversity shares common features. We all use DNA, we all descended from a common ancestor, we all live in the same environment with the same physical laws. Despite the variety, There are limits to what Earth life looks like and how it operates. Alien life would not share these constraints. It would have evolved independently, in environments potentially very different from Earth, solving the problems of existence in its own unique ways. The results might be literally unimaginable to us, so foreign that our brains evolved to recognize and categorize Earth life would struggle to even identify them as living things. What if their shapes are different? Not just variations on familiar themes, but fundamentally different architectures of existence. On Earth, bilateral symmetry is common among animals, left side mirroring right side. But what if alien life had radial symmetry, like a starfish but more complex? Or no symmetry at all, constantly shifting its form like an intelligent liquid? What if they live in places we cannot even imagine, on planets where the sky is orange because their star is a red dwarf, casting everything in rusty twilight, where the ground is made of frozen ammonia instead of rock and soil, where the oceans are not water but liquid methane, cold beyond our ability to survive, where the atmosphere is so thick that liquid and gas blur together and creatures swim through air that is almost a sea. Consider a world without a solid surface, a gas giant where life exists entirely in the clouds, floating on updrafts, feeding on organic compounds, synthesized by lightning. These beings would never touch ground because there is no ground to touch. They would be born aloft, live aloft, and die aloft, perhaps never even conceiving of the concept solid. Or imagine life on a rogue planet, a world ejected from its solar system, wandering through interstellar space without a sun. Such planets are dark and cold, but some might retain heat from their formation, or from radioactive decay in their cores. Life there would exist without sunlight, without seasons, without the rhythm of day and night. It would be blind, or perhaps see, using other senses we do not possess: echolocation, electromagnetic sensitivity, chemical detection. What about life based on different chemistry? On Earth, carbon is the foundation of all organic molecules, and water is the universal solvent. But silicon can form similar bonds to carbon, and ammonia can dissolve substances much like water does at lower temperatures. Could life use these alternatives? We do not know. Laboratory experiments have shown that silicon-based chemistry is much more limited than carbon-based, but that does not mean it is impossible. In the right environment, silicon life might thrive. There are even more exotic possibilities. Life based on plasma, in the atmosphere of a star, existing as patterns of magnetic fields and ionized particles. Life existing at incredibly slow or fast timescales. Beings that think and move so slowly they perceive years as we perceive seconds, or so quickly that our entire lifespan passes in what they would experience as a brief moment. Life that exists in multiple dimensions, or life that is distributed across vast distances, with no central body, but rather a network of nodes communicating and functioning as a collective organism. The more we consider the possibilities, the clearer it becomes that our imagination is limited by our experience. We can try to think outside the box, but we are still constrained by human perception, human concepts, human ways of understanding the world. True alien life might be so different that even if we encountered it, we might not recognize it. This has practical implications for our search. If we are looking for life that resembles Earth life in its chemistry and biology, we might miss entirely other forms that do not fit our expectations. We need to remain open, flexible, willing to be surprised. The universe is under no obligation to make sense to us, to present life in forms we find familiar or comfortable. And yet, there are constraints. Physics is universal. Chemistry is universal. Any life, anywhere, must obey the laws of thermodynamics, must find ways to extract energy from its environment, must be able to maintain itself against the entropy that seeks to tear all organized systems apart. These fundamental requirements might impose certain patterns, certain solutions that appear again and again across the cosmos. Perhaps there are convergent solutions to the problems of existence, ways of sensing the environment, ways of moving, ways of processing information that work so well they emerge independently on different worlds. Eyes, for instance, evolved independently, many times on Earth. Perhaps alien life would also develop eyes, or something serving the same function, because detecting electromagnetic radiation is such a useful ability. But even if there are convergent solutions, the specific implementations would vary wildly. Alien eyes might see wavelengths we cannot, might process visual information in ways completely different from our brains, might be located in places we would never think to look for them. The challenge of imagining alien life is also an opportunity. It forces us to question our assumptions, to think more deeply about what life is and can be. It expands our sense of possibility and reminds us that the universe is stranger and more wonderful than our everyday experience suggests. So when we search for alien life, we must search with humility and openness. We must be prepared for the unexpected, ready to recognize life in forms that challenge everything we thought we knew, and we must remember that our failure to imagine something does not mean it cannot exist. The universe has been surprising us for as long as we have been paying attention, and there is no reason to think it will stop now. The Fermi paradox. Why haven't we found anyone yet? The universe is so old and we are so young. 13.8 billion years have passed since the Big Bang. Our sun formed 4.5 billion years ago. Earth is approximately the same age. Humans in our modern form have existed for perhaps 200,000 years. Our technological civilization, the one capable of sending radio signals and building spacecraft, is barely a century old. In the vast sweep of cosmic time, we are newborns, infants, just opening our eyes for the first time. And yet, the universe has had billions of years before us, billions of years during which other civilizations could have arisen, matured, and spread across the galaxy. This is the essence of the Fermi paradox, named after physicist Enrico Fermi, who posed this question over lunch with colleagues in 1950. The paradox can be stated simply. Given the age of the universe, the number of stars and planets, and the apparent ease with which life arose on Earth, we should expect the galaxy to be teeming with intelligent civilizations. Some of them should be far older and more advanced than us. So why do we see no evidence of them? It is a haunting question, one that has spawned countless theories and explanations. Perhaps civilizations are common, but they do not last long. Perhaps they destroy themselves shortly after developing technology powerful enough to threaten their existence. Nuclear weapons, environmental destruction, artificial intelligence gone wrong, genetic engineering disasters. We know these dangers exist. We face them ourselves. Maybe the transition from a planetary species to a truly spacefaring civilization is so difficult that most fail. Or perhaps civilizations do survive, but they choose not to expand or communicate. Maybe once a species reaches a certain level of development, they turn inward, focusing on virtual realities or philosophical contemplation rather than physical exploration. Maybe the costs of interstellar travel are so enormous, the benefits so uncertain, that even advanced civilizations choose to stay home. There is also the zoo hypothesis, the idea that alien civilizations know about us but deliberately avoid contact, perhaps observing us from afar like researchers studying animals in their natural habitat. We are the uncontacted tribe, the protected reserve, left to develop on our own without interference. It is a comforting thought in some ways, suggesting we are not alone but rather watched over. But it is also untestable and perhaps unfalsifiable. We cannot prove we are not being secretly observed. Another possibility is that we are indeed among the first. The universe is old, but perhaps the conditions necessary for complex life have only recently emerged. Early generations of stars did not have enough heavy elements to form rocky planets. Perhaps only now, after billions of years of stellar evolution, is the galaxy becoming rich enough in the right elements for life-bearing worlds to be common. If so, we might be pioneers, early arrivals on a cosmic stage that will eventually host countless other civilizations. Or consider the possibility that interstellar travel is simply impractical. The distances are vast, the energy requirements enormous. Even at a significant fraction of light speed, journeys between stars would take decades or centuries. Perhaps no civilization, no matter how advanced, finds it worthwhile to actually go there. They might explore through telescopes, through robotic probes, through virtual simulations, but they do not send living beings across the void. There is something deeply philosophical about this paradox. It is not just a scientific puzzle, but an existential one. The answer we eventually discover, if we ever do, will tell us something profound about our own future. Are we destined to destroy ourselves, to stagnate, to spread among the stars, or to transcend physical existence entirely? The paradox also highlights how much we do not know. We speculate about alien motivations, alien choices, alien capabilities, but we have no data, no examples except ourselves. It is like trying to understand all of human culture by studying a single person. We might get some insights, but we would miss most of the picture. Perhaps the most unsettling aspect of the Fermi paradox is what it suggests about existential risks. If civilizations are common but we see no evidence of long-lived, expansive ones, maybe that means something prevents them from lasting or spreading. Maybe there is a great filter ahead of us, a challenge that most civilizations fail to overcome. We will explore this idea more deeply in the next section, but it looms over the Fermi paradox like a shadow. And yet, even as we contemplate these sobering possibilities, we must remember absence of evidence is not evidence of absence. We have been looking for such a short time with such limited tools across such a tiny fraction of the galaxy. The universe is vast beyond comprehension. Just because we have not yet found anyone does not mean no one is there. Maybe they are simply far away, beyond the range of our current detection capabilities. Maybe they existed long ago and are now extinct, their ruins waiting to be discovered. Maybe they will arise in the future, after we are gone. Or maybe they are here now, existing in forms or on scales we have not yet learned to recognize. The Fermi paradox invites us to question our assumptions. It asks us to think critically about our place in the cosmos, to consider possibilities both hopeful and troubling. It reminds us that the universe is full of mysteries we have barely begun to unravel. But perhaps most importantly, it teaches us patience and humility. We have been searching for such a brief time. We have explored such a tiny fraction of what is out there. To conclude anything definitive from our current lack of findings would be premature. The universe keeps its secrets well, revealing them slowly, only to those who persist in asking. So the paradox remains unresolved, hanging over our search like a question mark in the sky. Why haven't we found anyone? We do not know, but in not knowing, we remain open to wonder, to possibility, to the hope that tomorrow might bring the answer we seek. The great filter: is life rare? There is a concept in the search for extraterrestrial life that is both sobering and profound. It is called the Great Filter, and it addresses a simple but troubling question. In the journey from lifeless chemistry to spacefaring civilization, is there a step so difficult, so improbable, that most attempts fail? Think of it like this. The path from non-life to advanced civilization involves many stages. First, you need a suitable planet, stable orbit, right temperature, liquid water. Then simple organic molecules must form. Then self-replicating molecules. Then cells. Then multicellular life. Then complex organisms. Then intelligence. Then technology. Then stability enough to survive your own power and expand beyond your home world. Each of these steps is a filter, a hurdle that must be overcome. Some might be easy, others extraordinarily difficult. The Great Filter hypothesis suggests that at least one of these steps is so improbable that it prevents most potential civilizations from ever emerging. The crucial question is, where is the filter? Is it behind us or ahead of us? If the filter is behind us, if the hardest steps are the early ones, like the origin of life itself or the evolution of complex cells, then we might be extraordinarily lucky to exist at all. Life might be exceedingly rare in the universe, but if we have already passed the great filter, then our future is relatively secure. The hard part is done. We exist. We are intelligent. We have technology. The path ahead, while not without challenges, is at least passable. But if the filter is ahead of us, that is the frightening possibility. It would mean that something awaits most technological civilizations that they cannot overcome. Perhaps it is self-destruction through weapons of mass destruction. Perhaps it is environmental collapse. Perhaps it is something we have not even thought of yet, a consequence of advanced technology that inevitably destroys its creators. The Fermi paradox hints at this possibility. If life and intelligence are relatively common, but we see no evidence of long-lived, expansive civilizations, maybe that means most civilizations fail to survive their technological adolescence. Maybe we are approaching our own filter right now, in this critical century where we possess the power to drastically alter our planet and threaten our own existence. What if, like the stars, life is scattered, but each piece is fragile, struggling to survive? What if the universe is full of worlds where life began but never progressed beyond simple forms, full of planets where intelligence emerged but destroyed itself before reaching the stars? There is a poignant tragedy in this idea. Imagine civilizations throughout the galaxy, each one reaching a certain level of advancement, each one full of hope and curiosity, each one standing at the threshold of becoming something greater, and then failing. Not because they were evil or foolish, but simply because the challenges were too great, the balance too delicate, the margin for error too small. On Earth, we have come close to destroying ourselves several times. The Cold War brought us to the brink of nuclear annihilation. Climate change threatens our environment in ways that could make large parts of our planet uninhabitable. We face challenges from emerging technologies, artificial intelligence, synthetic biology, nanotechnology, whose consequences we do not fully understand. Are these challenges surmountable? Can we develop the wisdom to match our power? Or are we approaching a filter that we, like perhaps countless others before us, will fail to pass through? But there is another perspective on the great filter, one more hopeful. Perhaps the filter is not a single barrier, but rather a series of challenges, and different civilizations struggle with different ones. Perhaps some find the origin of life easy but never develop intelligence. Others develop intelligence but lack the cooperation needed for advanced technology. Still others achieve technology but cannot overcome their self-destructive tendencies. In this view, the path to spacefaring civilization is not impossible, just difficult and requiring many pieces to fall into place. We have made it this far, which suggests we have some combination of luck and capability. The challenges ahead are real, but they are not necessarily insurmountable. There is also the possibility that the great filter is not about destruction but about transformation. Perhaps advanced civilizations do not disappear. They simply change into something we would not recognize as a civilization. They might upload their consciousness into computers, or transcend physical existence, or retreat into virtual realities so compelling that physical space exploration loses its appeal. From our perspective, they would seem to have vanished, but they would simply have moved beyond our ability to detect or understand them. The Great Filter hypothesis reminds us of how precious and fragile our existence might be. If life is rare, if the path to intelligence and technology is filled with nearly insurmountable obstacles, then we carry a profound responsibility. We might be one of the few places in the universe where consciousness has emerged to contemplate the cosmos. To waste that, to destroy ourselves through carelessness or short-sightedness, would be a tragedy of cosmic proportions. But it also gives us agency and hope. Unlike natural disasters or random cosmic events, the challenges we face are ones we can potentially overcome through wisdom, cooperation, and foresight. The filter is not destiny. It is a test, and tests can be passed. As you contemplate the great filter, consider what it means for us here and now. Every choice we make about how to handle our technology, how to treat our environment, how to relate to each other, these are not just personal or political decisions. They are civilizational decisions, choices that might determine whether we pass through the filter or become another silent voice in the cosmic graveyard. Perhaps the journey to intelligent life is so difficult, so rare, that only a few civilizations ever make it past the stages we have reached. If so, then every moment of our existence is precious beyond measure. We are not just individuals or nations. We are representatives of Earth life, carriers of a spark that might be one of the rarest phenomena in the universe. The Great Filter hypothesis does not tell us our fate. It simply poses a question: can we be wise enough, careful enough, fortunate enough to survive ourselves? Can we pass through whatever filters lie ahead and become the spacefaring, long-lived civilization we aspire to be? The answer will be written by our actions, our choices, our collective wisdom or folly. And in that sense, the Great Filter is not just about alien life, it is about us, our future, our responsibility to ourselves and to the possibility of life throughout the cosmos. A cosmic family. What if life is everywhere? Now let us imagine a different possibility, one filled not with silence and emptiness, but with abundance and diversity. What if we have it backwards? What if life is not rare at all but common, even ubiquitous throughout the universe? Perhaps life isn't rare at all. It's simply waiting, blooming in corners of space we have yet to see. Think about Earth. Life emerged here remarkably quickly, within a few 100 million years after conditions became stable enough. To some scientists, this suggests that the origin of life might not be such an unlikely event after all. Given the right conditions, chemistry naturally moves toward complexity, toward self-organization, toward life. Perhaps it is inevitable, or nearly so. If this is true, then the universe might be teeming with living worlds. Not every planet, of course. Conditions must be right. But among the countless billions of rocky planets in the habitable zones of their stars, life might be common. Microbes thriving in subsurface oceans, photosynthetic organisms floating in alien seas, complex ecosystems evolving and adapting to their unique environments. Imagine looking up at the night sky and knowing that a significant fraction of those distant points of light are orbited by living worlds, that the universe is not a vast empty void punctuated by rare oases of life, but rather a garden, complex, diverse, abundant with possibility. In this scenario, we are not alone at all. We are part of a cosmic family, connected to countless other worlds through the shared experience of being alive. We are siblings in a sense, even if we have never met, even if we never will meet. We share the same universe, the same fundamental laws of nature, the same ultimate origin in the Big Bang. If life is common, why haven't we detected it? Perhaps because most of it is simple, microbes and primitive organisms that leave no technological signatures we could detect from light years away. Intelligence might be rarer than life itself. Complex multicellular life might be less common than single-celled, and civilizations capable of radio transmission might be rarer still. But even if intelligent, technological life is rare, the existence of abundant simple life would be profound. It would mean the universe is alive in a fundamental sense, that the spark we carry is not an isolated accident, but a widespread phenomenon, a natural expression of matter and energy, organizing itself into ever more complex forms. Consider what this means for our relationship with life on Earth. If life is rare, then Earth life is precious, unique, irreplaceable. But if life is common, Earth life is still precious, not because it is unique, but because it is our responsibility, our family, the form of life we are part of and accountable to. We would be stewards of one branch of a vast tree, caretakers of one expression of a universal phenomenon. There is comfort in the idea of a living universe. It makes existence feel less lonely, less precarious. We are not the only ones. Somewhere on a world we will never see, microbes are dividing, adapting, evolving. On another world, perhaps more complex life is emerging. The first animals exploring an alien seafloor, the first plants colonizing the land. On yet another, a different kind of intelligence might be pondering questions similar to ours. The cosmic family might be vast and diverse, including forms of life we cannot imagine, living in environments we would find utterly hostile, but we would all share the fundamental properties of life, the ability to maintain ourselves against entropy, to respond to our environment, to reproduce and evolve. In this shared struggle against disorder, we would be kin. This perspective also changes how we think about the future. If life is common, then the universe has potential we have barely glimpsed. Even if individual civilizations rise and fall, even if we never make contact with each other, life itself continues, experimenting, evolving, exploring the space of possible forms. The story is bigger than any single species or civilization. And perhaps, in some distant future, some form of life may be descended from us, maybe from another world entirely, maybe something that emerges billions of years from now will have spread far enough, learned enough, become sophisticated enough to begin connecting the scattered branches of the cosmic family to create not just a civilization, but a community of civilizations, diverse and strange, but united by the shared experience of consciousness and wonder. This is speculation, of course. We do not yet know if life is common or rare, but the possibility that we are part of a cosmic family, that life blooms throughout the universe in forms both familiar and strange, fills us with hope and wonder. It suggests that consciousness is not an accident, but a natural feature of the cosmos, that the universe has been moving toward awareness since its beginning. In this view, we are not isolated observers of a dead universe, but participants in a living one. We are part of the story, not separate from it. And every living thing on Earth, every bacterium, every plant, every animal, is part of that same story, carrying forward a spark that might illuminate worlds we will never see. So when you look at the stars tonight, and I hope you will, after this journey through contemplation and wonder, take a moment to truly see them, not just glance upward and note their presence, but really look, find a place away from bright lights if you can, where the sky opens up above you in its full glory. Let your eyes adjust to the darkness, giving them time to become sensitive to the faint light that has traveled for years, decades, centuries, or even millennia to reach you. Consider the possibility, as each point of light resolves in your vision, that many of them are orbited by living worlds. Not all of them, certainly. Some stars are too young, too old, too massive, or too variable to host stable planetary systems. But many of them, perhaps most of them, have planets circling them in their gravitational embrace. And among those planets, on how many might conditions be right for life? Think about a star you can see right now. Pick one, any one. Perhaps it is Sirius, the brightest star in our night sky, blue, white, and brilliant. Or perhaps Betelgeuse, the red supergiant marking the shoulder of Orion, a star so large that if placed where our sun is, it would extend past the orbit of Mars. Or perhaps it is a dimmer star, one you can barely see, one whose name you do not know, and most stars fall into this category, unremarkable to our eyes, but no less real, no less important in the cosmic scheme. Around that star, invisible to you at this distance, there might be planets, rocky worlds like Earth, or gas giants like Jupiter, or something in between, or something entirely different that we have not yet imagined. And on one of those worlds, if conditions are right, there might be oceans. Perhaps they are water oceans like ours, salty and vast, their surfaces rippled by winds and warmed by the star's light. Or perhaps they are oceans of something else, liquid methane on a frigid world, or even more exotic fluids in conditions we have never encountered. In those oceans, or in the atmosphere above them, or in caverns beneath the surface, or in environments we cannot yet conceive, there might be life. Perhaps it is simple, single-celled organisms, microscopic and humble, but alive nonetheless, carrying out the essential functions of life: metabolism, reproduction, response to environment, maintaining order against entropy. Perhaps it has been there for billions of years, evolving slowly, diversifying into countless forms, filling every available niche in their world's ecosystems. Or perhaps it has gone further. Perhaps, somewhere in that distant system, life has evolved complexity, multicellular organisms, creatures with specialized tissues and organs, beings that move and sense and respond to their world in sophisticated ways. Perhaps they have nervous systems, brains, the capacity for learning and memory. Perhaps some of them have even developed intelligence, consciousness, self-awareness. Imagine them there, on their world, living their lives entirely unaware of you, as you are unaware of them. What are they doing at this moment? Are they hunting for food or fleeing from predators? Are they raising their young, teaching them the skills they will need to survive? Are they cooperating with others of their kind, forming societies, developing cultures? Are they looking up at their own night sky, seeing our sun as one faint point among many, wondering if anyone else is out there? The universe is not empty but full. This is not wishful thinking or hopeful speculation, but a conclusion based on what we have learned. Full of matter, atoms and molecules and dust and gas, all the raw materials of existence. Full of energy, light streaming from countless stars, heat radiating from planetary cores, gravitational potential energy, kinetic energy, the energy locked in atomic bonds. Full of structure, galaxies and clusters of galaxies, stars and planets, organized patterns emerging from the chaos of the Big Bang. And if the universe is full of these things, why should it not also be full of life? Life is not separate from matter and energy. It is a particular arrangement of them, a particular pattern that emerges when conditions are right, and conditions are right in many, many places. Not everywhere, not on every world, but on enough worlds that life might be common, even abundant. The universe might not be silent, but simply speaking in languages we have yet to learn. Think about that for a moment. What if signals are passing through you right now, electromagnetic radiation carrying information from distant civilizations, and you simply do not recognize them as meaningful? We listen for radio signals, for specific patterns that would indicate intelligence. But what if advanced civilizations have moved beyond radio, using quantum entanglement or gravitational waves or methods we have not discovered yet? Or what if the signals are there, in the radio spectrum we monitor, but we do not recognize them because they are so different from what we expect? We look for patterns we understand, repeating sequences, mathematical relationships, encoded information in formats we can imagine. But what if alien communication uses principles we have not thought of, structures we would not recognize as carrying meaning? It is like listening for speech, when what is actually being transmitted is music, or looking for writing when the message is encoded in color, or scent, or some other medium we have not considered. The universe might be full of conversation, and we are like someone who has not yet learned language, hearing sounds but not yet understanding that they carry meaning. We are not alone, but part of something vast and beautiful. Even if we never detect another civilization, even if we search for centuries or millennia without finding definitive proof of extraterrestrial life, we are still connected to everything that exists. We are made of atoms that came from stars. We orbit a star that is one among billions. We live in a galaxy that is one among billions. We are part of the universe, not separate from it. And if life does exist elsewhere, whether as microbes or complex organisms or intelligent civilizations, then we are part of a cosmic community bound together by the shared miracle of being alive. We are family, in the deepest sense, related not through genetics but through shared origin, shared chemistry, shared participation in the grand experiment of existence. This community might be vast beyond our ability to comprehend. There might be billions of living worlds, each one hosting its own unique biosphere, its own evolutionary journey, its own story of life's emergence and diversification. Some might be just beginning, with life in its earliest stages, simple organisms just starting to explore what is possible. Others might be ancient, with billions of years of evolutionary history behind them, complexity built upon complexity, forms of life we cannot imagine. And among all these worlds, there might be thousands or millions where intelligence has emerged, not all at the same time. The universe is too vast for that, and the timescales too long. Some civilizations might have risen and fallen billions of years ago, leaving no trace we could detect from here. Others might be emerging now, just developing the capacity for abstract thought and complex communication. Still others might not emerge for billions of years in the future, arising on worlds that are still being formed. But we are all of us, every living thing on every world, part of the same family, united by the simple but profound fact of existence. We all fight the same battle against entropy. We all maintain ourselves through metabolism, taking in energy and matter from our environments, and using it to preserve and reproduce our patterns. We all evolve, adapting to our circumstances, exploring the space of possible forms. We all, in our own ways, respond to the mystery of being alive. Whether this is true or not, whether life is abundant or rare, whether we will ever find evidence of it beyond Earth, the possibility itself transforms how we see our place in the universe. The very fact that we can ask the question, that we can contemplate the possibility of other living worlds, changes us. It expands our perspective beyond our immediate concerns, beyond our planet, beyond even our own time. It invites us to think on cosmic scales, to consider questions that span billions of years and countless light years of space. It humbles us, reminding us that we are small, but it also empowers us, showing us that we can understand things far beyond our direct experience. We are not cosmic orphans, abandoned and alone in an indifferent universe. We might be one member of a vast family, or we might be a young family just beginning our story, or we might be unique, but in any of these cases we belong. We are not accidents or mistakes. We are natural expressions of what the universe can do, what matter and energy can become when organized in particular ways. Think about what it means to be part of the largest family imaginable. All life, everywhere, throughout all of time, united by the simple but profound fact of existence. Every bacterium that has ever lived on Earth, every tree, every insect, every fish, every bird, every mammal, every human being who has ever drawn breath, all of us are family, descended from a common ancestor that lived billions of years ago. We share the same basic biochemistry, the same genetic code, the same cellular machinery. And if life exists elsewhere, they too are family, though the relationship is more distant. We would not share a common ancestor. Our lineages would have originated independently, but we would share a common origin in the chemistry of the cosmos, in the atoms forged in stars, in the laws of physics that govern how matter behaves. We would be parallel experiments in what life can be, different solutions to the same fundamental problem of how to exist and persist in a universe that tends toward disorder. This family would be diverse beyond imagining. On Earth alone, life has explored countless forms, from the simplest bacteria to the most complex animals, from organisms that thrive in boiling water to those that survive in Antarctic ice, from microscopic plankton to enormous whales. And Earth is just one world with one evolutionary history. Imagine the diversity that might exist across billions of worlds, each with its own unique conditions, its own evolutionary pathways, its own forms of life. Some of these worlds might host life that is recognizably similar to ours, carbon-based, DNA-using, water-dependent. The underlying chemistry might be so advantageous that it emerges independently on many worlds, but others might be radically different, using different molecules, different solvents, different energy sources. The family would include forms of life so strange we might struggle to recognize them as alive at all. And yet, beneath all this diversity, there would be unity. All of us, all life, everywhere, would share certain essential properties. We would all maintain ourselves against the natural tendency toward disorder. We would all respond to our environments. We would all reproduce, passing on information to the next generation. We would all evolve, changing over time in response to selection pressures. These fundamental characteristics would bind us together as family, even across the gulfs of space and difference. Throughout all of time, this is the temporal dimension of the family. Not just life that exists now, but life that has existed in the past and will exist in the future. On Earth, over 99% of all species that have ever lived are now extinct. They are gone, but they were part of the family. They lived, they struggled, they reproduced, they mattered, and countless species will arise in the future. Descendants of life forms alive today, evolved into forms we cannot predict. The same is true across the cosmos. If life is common, then countless lineages have already come and gone, their worlds now silent, and countless more will arise in the future, on worlds yet to be born, continuing the grand experiment of existence long after our sun has died, and our species, if we still exist in any form, has moved on or transformed into something new. United by the simple but profound fact of existence, this is what binds the family together. Not shared genetics, not shared history, not shared culture or communication, but the simple reality that we all exist, we all live, we all participate in the universe's capacity to organize matter into patterns that persist and grow and change and adapt. Existence itself is the miracle that anything exists at all, rather than nothing, that the universe is not empty, but contains matter and energy, that this matter and energy can organize itself into structures of increasing complexity, that some of these structures can maintain themselves, can reproduce, can evolve, that consciousness can emerge, allowing the universe to become aware of itself. This is the foundation of the cosmic family, the shared ground on which all of existence rests. The message we send. What will we say to them? If there are others out there, and after this journey of contemplation, this exploration of possibility, perhaps you feel differently about whether there might be, if we ever make contact or they make contact with us, what will we say? This is not an idle question, or a distant hypothetical. It is immediate, pressing, profound. How do we introduce ourselves to minds that might be utterly alien to us? Consciousness that emerged through entirely different evolutionary pathways, intelligence that might think in ways we cannot imagine. What message could possibly speak for all of humanity? Not just for one culture or one nation or one time period, but for the entire diverse, contradictory, beautiful, flawed species we are. How do we represent ourselves fairly, honestly, completely? What do we choose to show, and what do we choose to hide? And beyond humanity, what message could speak for all of Earth, for the entire biosphere that has produced us, for the billions of years of evolutionary history that led to this moment. What message could speak for the entire journey that brought us to this moment, from the Big Bang to the formation of galaxies, to the ignition of our sun, to the cooling of Earth, to the emergence of life, to the evolution of intelligence, to the development of technology, to this precise instant when we are capable of sending signals into space and wondering if anyone will receive them? This is not a hypothetical question. We have already sent messages. We have already made choices about how to represent ourselves to the cosmos. In 1972 and 1973, NASA launched the Pioneer 10 and Pioneer 11 spacecraft on trajectories that would take them out of the solar system and into interstellar space. These were humanity's first emissaries to the stars, physical objects carrying a piece of us into the cosmic ocean. Attached to each Pioneer spacecraft was a golden plaque, a metal plate measuring about 6 inches by 9 inches, designed by the renowned astronomer Carl Sagan and his colleague Frank Drake. This plaque was humanity's first deliberate message to any potential extraterrestrial intelligence that might encounter the spacecraft in the distant future. Think about that responsibility, that challenge. How do you introduce your entire species, your entire world, your entire solar system, in a single image that might not be discovered for millions of years, if ever? The plaque shows the figure of a man and woman, nude and unadorned, standing before an outline of the Pioneer spacecraft to provide scale. The man's hand is raised in a gesture of greeting, a simple, peaceful gesture, though one wonders if beings that evolved entirely separately would interpret it that way. The figures are shown in the style of technical drawings, simplified and idealized, representing no particular ethnicity but attempting to show general human form. Behind the figures, there are lines radiating from a central point, showing the position of our solar system relative to 14 pulsars, rotating neutron stars that emit regular pulses of radiation. Each line indicates the direction and distance to a pulsar, and the pulses are shown in binary code along each line. This is a cosmic map, a way of saying this is where we are to anyone who might find the spacecraft. Pulsars were chosen because their periods are precise and distinctive, making them useful as landmarks. Even millions of years from now, if the spacecraft is found, the pulsar's periods will have changed in predictable ways, allowing whoever finds it to calculate when the spacecraft was launched. The plaque also shows the structure of hydrogen, the most common element in the universe, as a unit of measurement. A hydrogen atom in its 2 lowest energy states is depicted, with the wavelength of radiation emitted during the transition shown in binary. This provides a universal standard, a way to communicate sizes and distances to any civilization that understands chemistry and physics. At the bottom of the plaque is a diagram of our solar system, the Sun and 9 planets as they were understood at the time. This was before Pluto was reclassified, with the trajectory of the Pioneer spacecraft shown launching from the 3rd planet. This says, "We come from here. This is our home. This is the world that produced us." It is a greeting card from Earth, traveling through interstellar space at tens of thousands of kilometers per hour, carrying its message of introduction into the eternal night. Will anyone ever find it? The odds are vanishingly small. Space is vast, the spacecraft tiny, and the universe mostly empty, but the possibility exists. Someday, billions of years from now perhaps, long after humanity has either gone extinct or evolved into something unrecognizable, the Pioneer spacecraft might pass within range of another solar system, another world, another civilization. And if they have the technology to detect it, to retrieve it, to decode its message, they will know once on a small world orbiting an average star, there were beings who wondered about the cosmos and who reached out in hope. In 1977, NASA launched something even more ambitious. The Voyager 1 and Voyager 2 spacecraft, also on trajectories that would eventually take them beyond our solar system, and attached to each Voyager was the Golden Record, a phonograph record, literally made of gold-plated copper to resist the harsh environment of space, containing a far more elaborate message than the Pioneer plaques. This was a collection of sounds and images meant to represent Earth and its inhabitants, curated by a committee chaired by Carl Sagan. Think about the challenge. You have a record that can hold about 90 minutes of audio and 116 images. What do you put on it? How do you represent an entire world, an entire species, an entire biosphere in such limited space? They chose music from different cultures and eras. Western classical music. Yes. Bach's Brandenburg Concerto No. 2. Beethoven's Fifth Symphony. Mozart, Stravinsky. But also music from around the world. Javanese gamelan, Senegalese percussion, Indian raga, Japanese shakuhachi, Aboriginal songs from Australia, Georgian folk music, Peruvian panpipes, blues and jazz represented by Louis Armstrong and Chuck Berry's Johnny B. Good, the first rock and roll song to leave the solar system. The music spans cultures and centuries, showing the incredible diversity of human musical expression. Greetings in 55 languages, from ancient Sumerian and Akkadian to modern Mandarin and English, each offering a brief hello to whoever might be listening. Peace in Urdu. Friends of space. How are you all? Have you eaten yet? In Amoy. Good health to you now and forever. In Welsh. Each greeting chosen to represent not just linguistic diversity, but the human desire to connect, to reach out, to acknowledge the other. Sounds of nature. Wind, rain, thunder, surf, animal calls from the rich symphony of Earth's biosphere. Birds singing at dawn, crickets chirping at dusk, whales calling in the ocean depths, chimpanzees hooting in the forest, the footsteps of a human walking, the sound of a heartbeat, a kiss, a mother's first words to her newborn child, the natural and the human, the wild and the civilized, all woven together into a portrait of our world. Images of humans, of course, a man and woman, a family, children, faces showing different emotions and ethnicities, but also images of our cities and landscapes, our buildings and roads, our farms and factories, the Great Wall of China and a modern highway, a string quartet and a page from Newton's Principia Mathematica, a diagram of our DNA structure and an illustration of cell division, a photograph of our planet as seen from space, that famous blue marble image showing a world of swirling white clouds, blue oceans, brown and green continents, all against the black velvet of space. What message will we send to the stars? What words would speak for us, for all that we are and have been? This question remains open, evolving as we evolve, as our understanding of ourselves deepens and changes. The messages we send now might be different from those we sent in the 1970s, reflecting new knowledge, new values, new priorities. The challenge is enormous, almost overwhelming when you really think about it. How do you communicate with something that might not see, hear, or think the way you do? Human language. All human languages assume certain shared experiences that seem universal to us, but might not be universal at all. They assume the passage of time from past to future, the existence of discrete objects with boundaries, spatial relationships of near and far, up and down, inside and outside. But would an alien consciousness share these concepts? Would they experience time as we do, as a linear flow from past through present toward future? Or might they experience time differently, all at once perhaps, or cyclically, or in some way we cannot imagine because we are trapped in our own temporal perception? Would they pass reality into discrete objects the way we do, seeing a tree as separate from the ground and the air and the sky? Or might they perceive the universe as a continuous field of relationships, with no clear boundaries between things? Would they have senses like ours? We experience the world primarily through vision, hearing, touch, smell, and taste. But these are not the only possible senses. Other species on Earth use echolocation, electrical field detection, magnetic field sensing, infrared vision, ultraviolet vision. An alien species might have entirely different sensory modalities, perceiving aspects of reality we are completely blind to and missing aspects we take for granted. How do you describe color to a being that has no visual sense? How do you explain sound to something that does not hear? Mathematics is often suggested as a universal language, a way to establish initial contact and build common ground. The ratio of a circle's circumference to its diameter is pi, approximately 3.14159, everywhere in the universe. It does not matter who is measuring or what system they use. This ratio is a fundamental property of geometry that cannot be otherwise. Prime numbers are prime regardless of who is counting. 2, 3, 5, 7, 11, 13, and so on. Numbers divisible only by themselves, and 1, following patterns that emerge from the structure of arithmetic itself. Physical constants do not change based on who is observing them. The speed of light in vacuum is the same everywhere and always. The gravitational constant, the charge of an electron, the mass of a proton, these are fundamental properties of our universe, numbers that any scientifically advanced civilization would have measured and would find to be the same as we measure them. Perhaps through these shared constants, through the universal language of mathematics and physics, we could establish common ground, build a foundation for more complex communication. But mathematics alone cannot convey the richness of human experience, the depth of our emotions, the complexity of our cultures, the things that make life worth living beyond mere survival. How do you explain love in equations? The feeling of holding your child for the first time, the bond between parent and offspring, the willingness to sacrifice for those we care about. These are real, important aspects of human existence, but they do not reduce easily to numbers and formulas. How do you describe music to something that might not hear? You can describe it technically: frequencies, wavelengths, amplitude, harmonics, mathematical relationships between notes. But that misses what music is, what it means, how it moves us emotionally. A mathematical description of Bach's Brandenburg Concerto would be complete but would entirely fail to capture what makes it beautiful, what makes it meaningful. How do you share the beauty of a sunset with something that might not see visible light? You can describe wavelengths, the sun's light scattered by Earth's atmosphere, shorter wavelengths scattered more than longer ones, leaving the red and orange to dominate the sky near the horizon. But the experience of watching a sunset, the emotions it evokes, the sense of peace or wonder or melancholy, these cannot be transmitted through spectroscopy. Perhaps the best we can do is send representations of ourselves, symbols, sounds, images, and hope that whoever receives them has enough sophistication to decode them, or at least to recognize them as attempts at communication. The golden record includes a stylus and instructions in symbolic form on how to play it, etched onto the record's cover. The instructions show how to attach the stylus, how fast to rotate the record, how to decode the audio and video information. But will anyone understand? Will they have the concept of recording and playback, of storing information in physical media and later retrieving it? Will they recognize the grooves as encoded information rather than random texture? Will they be able to reproduce the precise speed and stylus pressure needed to decode the signal without destroying the record? These are not guaranteed. We have created messages based on our own technology and assumptions, and there is no certainty that another civilization would think the same way. Some scientists have suggested that any message we send should emphasize mathematics, physics, and biology, objective facts about our world and ourselves. Send the periodic table, showing which elements we have discovered and understand. Send our understanding of fundamental forces and particles. Send the structure of DNA and the basic biochemistry of life as we know it. These are universal truths within our universe, at least. Facts that any scientifically advanced civilization would recognize and understand. They provide common ground, a shared foundation of knowledge on which to build communication. Others argue for including art, music, and expressions of emotion, even if they are harder to decode and might be misunderstood or not understood at all. Yes, they say, we should communicate scientific facts, but we should also communicate what makes us human, what gives life meaning beyond mere survival and reproduction. We should share our capacity for beauty, for creativity, for finding meaning in patterns of sound or color or movement. We should show that we are not just biological machines, but beings with inner lives, with emotions and aspirations and the capacity for wonder. The debate reflects deeper questions about what defines us, what is most important about humanity. Are we primarily our scientific achievements, our understanding of physical laws, our technology, or are we our art and culture, our emotions and relationships, our search for meaning and beauty? The answer, of course, is that we are all of these things, inseparably intertwined. Our science emerges from our curiosity, which is an emotional and philosophical drive. Our art reflects our understanding of patterns and structures, which is cognitive. We cannot separate the different aspects of ourselves into neat categories. There is also the question of whether we should send messages at all, whether we should deliberately announce our presence to the cosmos. Some scientists and thinkers argue that revealing our presence to the cosmos is dangerous, that we do not know what is out there, or how they might respond. The universe could be hostile, full of civilizations that view others as threats to be eliminated, or resources to be exploited. Broadcasting our location might be inviting catastrophe, alerting potential enemies to our existence before we are capable of defending ourselves. This is sometimes called the dark forest hypothesis, popularized by science fiction writer Leo Kixin. In this view, the universe is like a dark forest at night, with civilizations like hunters moving quietly, trying not to draw attention to themselves because revealing your position makes you a target. Any civilization that announces itself too loudly might be destroyed by others who see them as a threat. The only way to survive is silence, stealth, hiding in the darkness, and hoping no one notices you. It is a chilling perspective, one that casts the silence of the universe in a sinister light. Perhaps there are many civilizations out there, but they are all hiding from each other, afraid to make contact, creating a galaxy of paranoid isolation. In this view, our broadcasts might be a terrible mistake, an act of cosmic foolishness that will be punished when predatory aliens locate us. Others counter that any civilization advanced enough to receive our signals and travel to Earth would already have the technology to detect our presence through other means, whether we deliberately send messages or not. Radio and television broadcasts have been leaking into space for over a century now, an expanding bubble of electromagnetic radiation announcing our existence to anyone capable of detecting it. Our atmospheric composition has been altered by industrial activity in ways that could be detected by distant observers analyzing our planet's spectrum. The presence of industrial pollutants, changes in oxygen and carbon dioxide levels, signs that something is modifying the planet's chemistry. If someone is looking for us, really looking with powerful enough technology, they can find us whether we deliberately send messages or not. Our presence is already known to anyone within 100 light years who has the technology to detect radio signals or analyze planetary atmospheres. Deliberately sending messages does not significantly increase our risk because we are already detectable. Moreover, some argue that any civilization advanced enough for interstellar travel would have solved the basic problems of resources and survival that drive conflict on Earth. They would have abundant energy from their star, sophisticated technology for manufacturing, perhaps even the ability to create whatever they need from basic elements. What would they want from us? Our resources? The universe is full of planets with water, with metals, with organic compounds. Our location? Space is vast. We pose no threat to anyone light years away. Our biological distinctiveness? Perhaps, but forceful conquest seems like an inefficient way to study us. But perhaps the most compelling argument for sending messages is philosophical rather than strategic. It is an act of hope, of reaching out, of affirming that connection matters even across impossible distances. In sending a message, we express our belief that consciousness is valuable wherever it arises, that communication is worthwhile even if it takes millennia to complete a single exchange, that we are willing to try to bridge the gap between different forms of awareness, however alien they might be. It is an expression of optimism about the universe and our place in it. It says, we believe that reaching out is better than hiding. We believe that communication is possible, even across vast differences. We believe that consciousness naturally desires connection, that being aware means wanting to share that awareness with others. We refuse to live in fear and isolation, even if that means taking risks. The message we send is also, in a profound sense, a message to ourselves. It forces us to reflect on who we are, what we value, what we want to preserve and share. In choosing what to include on the Golden Record, Carl Sagan and his team had to make decisions about what represents humanity, not just what we are now, but what we have been and what we aspire to be. They chose diversity, many languages, many musical traditions, many ways of being human. They did not try to present a false unity, a single human culture, but rather celebrated the rich variety of human expression. They acknowledged that we are not one thing but many things, that humanity speaks with many voices, creates beauty in many forms, understands the world through many different cultural lenses. They chose beauty, art, and music alongside scientific information. They did not present ourselves as purely rational beings, as biological computers concerned only with facts and survival. They showed our capacity for aesthetic appreciation, for creating and enjoying patterns that serve no immediate survival purpose, but that enrich our existence nonetheless. They showed that we find meaning in beauty, that creating and sharing beautiful things is part of what makes us human. They chose honesty, including both the best of humanity and hints of our struggles. The record includes images of humans at war alongside images of humans in peace. It shows technological achievement alongside natural landscapes. It acknowledges that we are not perfect, that our history includes conflict and destruction, as well as creation and cooperation, but it emphasizes the better aspects of our nature, the things we are proud of, the things we hope to be judged by. If we were to send another message today, decades after the Voyager probes were launched, what would we add? What new knowledge, new technology, new cultural expressions have emerged that should be shared? Images of our cities lit up at night, visible from space, showing the extent of human civilization across the planet. Representations of the internet, of digital technology, of the unprecedented interconnection we have achieved. Evidence of climate change, of our impact on our world, showing both our power and our responsibility. Would we include warnings about the challenges we face, the dangers of advancing technology without corresponding wisdom? Or would we focus on our efforts to address these challenges, our growing environmental awareness, our attempts to become better stewards of our planet? Representations of our digital technology, of artificial intelligence, of genetic engineering, of all the ways we are gaining power over matter and life. Would we show these as triumphs of human ingenuity, or as warnings about the double-edged nature of knowledge and capability? Or would we focus on timeless things that remain as true now as they were when the Voyager record was created? The night sky, unchanged in human timescales, still filled with stars and mystery. The ocean, vast and deep, source of life and inspiration. The connection between parent and child, the bond that transcends culture and era, fundamental to who we are as a species. The capacity for wonder, for curiosity, for asking questions about existence. These things do not change with technology or time. Maybe the message doesn't need to be complete or perfect. Maybe attempting to fully represent ourselves in any message is impossible. We are too complex, too contradictory, too diverse to be captured in any finite communication. Maybe the act of sending it is more important than its content, more meaningful than whatever specific information we choose to include. Because in sending a message, we are doing something profound. We are saying, we are here, we exist, we are aware of the cosmos and our place in it. We wonder about you, whoever and wherever you are. We hope you receive this in the spirit it is sent, not as a threat or a territorial claim or a demand, but as a greeting from one form of consciousness to another, an invitation to communicate, an expression of our belief that connection across the cosmic distances is possible and worthwhile. We are saying, look, here is what we have discovered about the universe. Here is what we have created with matter and energy. Here is how we express ourselves through sound and image and pattern. Here is what moves us emotionally, what we find beautiful, what gives our lives meaning. We offer this to you freely, hoping that you might understand, might appreciate, might reciprocate. And perhaps somewhere in the cosmos, another civilization has sent their own message, carrying their own introduction, their own attempt to share who and what they are. Maybe it is already traveling through space, headed in our direction, electromagnetic whisper crossing the light years at the speed of light itself, carrying their hopes for contact, their dreams of not being alone, their own carefully chosen representations of what makes them who they are. Maybe we will receive it someday, tomorrow, or 1,000 years from now, or never. But the possibility remains. The hope persists. The invitation stands open. We have reached out. We have said hello. And in doing so, we have affirmed something essential about ourselves, that we are beings who wonder, who hope, who reach across impossible distances seeking connection, seeking to know and be known, seeking to transform the silence of space into a conversation between minds. And perhaps, somewhere in the cosmos, another civilization has sent their own message. Maybe it is already traveling through space, headed in our direction, carrying their attempt to introduce themselves, to share their existence, to say, you are not alone. The messages we send ripple outward at the speed of light, expanding spheres of information traveling through the void. They will outlast us, outlast our civilization, outlast perhaps even our species. Long after we are gone, these messages will continue their journey, representing a moment when humanity looked up at the stars and tried to make contact. There is something beautiful and melancholy about this. We send these messages knowing we will almost certainly never receive a response, that the distances and timescales involved make dialogue impossible. But we send them anyway because the gesture matters, because reaching out is part of who we are. What message will you send? Not literally into space, but in your life, through your actions, through how you treat others and care for your world. You are part of humanity's message, whether you intended to be or not. Your existence, your choices, your impact, these are all part of what speaks for Earth, for life, for consciousness. In that sense, we are all messages in motion, carrying forward the story of life on Earth, expressing through our existence that awareness, curiosity, compassion and wonder are possible in this universe. That matter can organize itself into forms that not only exist but contemplate their existence and reach out to connect with others who do the same. Philosophy. What does this all mean for us? We have traveled far in our journey tonight, from the birth of stars to the search for signals, from microbes to civilizations, from silence to possibility. But now, as we near the end of our exploration, we must turn inward and ask, what does all of this mean for us? Why does the question of extraterrestrial life matter so deeply? If we are not alone, What does that say about us? What are we really searching for? On the surface, the search for extraterrestrial life is scientific, a question of biology, chemistry, astronomy. But beneath that surface lies something far more profound. We are searching for meaning, for context, for an understanding of our place in the vast cosmos. For most of human history, we believed we were the center of everything. Earth was the center of the universe. Humans were the pinnacle of creation. Our existence was the point around which everything else revolved. But science has humbled us repeatedly. Earth is not the center. It is one planet among billions. Our sun is not special. It is one star among hundreds of billions. Our galaxy is not unique. It is one among hundreds of billions. This has been called the Copernican principle. We are not special, not central, not the point of it all. It is a principle that has guided science for centuries and has been vindicated again and again. And yet we cling to one last bastion of uniqueness, perhaps life, consciousness, intelligence. These are special. Perhaps we are the only ones, or nearly so. The discovery of extraterrestrial life, especially intelligent life, would complete this humbling. It would say, you are not unique even in this. Consciousness has arisen elsewhere. You are one expression among many of the universe's capacity to become aware of itself. For some, this would be devastating, a final blow to human significance. If we are not special, if we are just one among countless others, then what is the point? Why does our existence matter? But there is another way to see it, one that is not diminishing but liberating. If we are not unique, we are also not alone. Our struggles, our questions, our hopes, these might be universal experiences, shared by countless others across space and time. We are part of something larger than ourselves, part of a community of consciousness that spans the cosmos. The meaning of connection and the quest for knowledge, framed as a deeply personal, spiritual journey, becomes clearer in this light. We seek extraterrestrial life not to diminish ourselves, but to contextualize ourselves, to understand what it means to be alive and aware in a universe that allows for such things. And whether we find others or not, the search itself changes us. It makes us think more carefully about what life is, what consciousness is, what we value and why. It encourages us to look at our own world with fresh eyes, to appreciate the extraordinary nature of our existence. Consider this. We are made of atoms forged in stars, organized by billions of years of evolution into forms capable of contemplating the stars themselves. We can look up at the night sky and understand what we are seeing, not just lights but suns, galaxies, the very history of the cosmos written in starlight. We can ask questions about our origins and our fate. We can create art, music, literature that expresses the inexpressible. We can love, dream, wonder. This is miraculous, whether we are alone or not. The question of extraterrestrial life does not determine our worth. It only provides context. If we are alone, then we carry a profound responsibility. We are the universe's only way of knowing itself, and we must preserve and nurture that capacity. If we are not alone, then we are part of a cosmic community, and we have the opportunity to learn from and connect with others. The search also highlights our shared humanity. In contemplating extraterrestrial life, national boundaries and cultural differences seem trivial. We are all Earth life, all products of the same evolutionary journey, all sharing this small world in the vastness of space. The perspective from orbit, the overview effect as it is called, reveals no borders, no divisions, just one living world, precious and fragile. Perhaps this is the deepest meaning of the search. It reminds us of what we share, not what divides us. It puts our existence in perspective, not to diminish us but to help us see more clearly. Our problems, political conflicts, economic inequalities, environmental destruction, these are solvable, human-scale challenges. We have the capacity to address them if we choose to, if we recognize our shared fate. The question of extraterrestrial life is also a question about time and mortality. Civilizations, like individuals, are temporary. We arise, flourish for a time, and eventually fade. But in our brief moment of existence, we can create, discover, connect, love. We can leave a mark, however small, on the vast canvas of space and time. If we one day make contact with another civilization, we might learn how they have grappled with these same questions. How do they find meaning? How do they handle the knowledge of their own temporariness? How do they structure their societies, their ethics, their relationships? The insights could be transformative, offering us new ways of being, new possibilities for organizing our existence. But even without contact, even in the silence, we can learn. The search for extraterrestrial life forces us to imagine other ways of being alive, other forms of consciousness, other approaches to existence. It expands our moral circle, making us consider the rights and value of beings utterly different from ourselves. If we can extend compassion and respect to hypothetical aliens, surely we can extend it to different humans, to animals, to all forms of Earth life. The philosophical implications ripple outward in every direction. Questions of religion and spirituality, of ethics and morality, of identity and purpose, all are touched by the question of whether we are alone. Different people will answer these questions differently, and that diversity of perspective is itself valuable. There is no single correct way to find meaning in a possibly populated or possibly empty universe. What matters is that we continue asking, continue wondering, continue exploring both outer space and inner space. The cosmos beyond and the consciousness within. The search for extraterrestrial life is ultimately a search for ourselves, for understanding what we are and what we might become. As you lie here now, contemplating these questions, you are participating in one of humanity's oldest and deepest traditions, the attempt to understand our place in the cosmos. Your thoughts, your feelings, your sense of wonder, or fear, or hope, these are part of the collective human response to the mystery of existence. And in that sense, you are not separate from the search. You are part of it. Your existence is part of the answer to the question, is there intelligent life in the universe? Yes, there is. Here now. In you wondering about itself, reaching out across the void of ignorance toward understanding. Cosmic connection. We are not alone, but we are part of everything. As we approach the end of our journey, let us consider one final perspective, one that transcends the question of whether other civilizations exist and touches something even deeper. We are part of the cosmos. As we look to the stars, we realize we are the stars, we are the life we seek. This is not metaphor or poetry, though it sounds like both. It is literal truth. The atoms in your body were created in the cores of stars billions of years ago. When those stars died, they scattered their enriched material across space, and eventually that material coalesced into new stars, new planets, new forms of organization, including you. You are stardust, quite literally. The calcium in your bones was created in a supernova. The iron in your blood was forged in stellar fire. The oxygen you breathe, the carbon in your cells, the nitrogen in your DNA, all of it came from stars. You are made of the cosmos, and the cosmos is made of you. But it goes deeper than chemical composition. You are not just made of stardust. You are stardust that has organized itself to contemplate its own existence. You are the universe becoming self-aware, developing the capacity to understand its own history and nature. Think about that for a moment. For 13 billion years, the universe evolved from simple hydrogen and helium to complex chemistry, from chemistry to life, from simple life to complex consciousness. And now, in you, the universe has developed eyes to see itself, a mind to understand itself, a heart to wonder at itself. In this sense, you are not separate from the cosmos, observing it from the outside. You are the cosmos, observing itself. Every time you look up at the night sky and wonder, that is the universe wondering at its own beauty. Every time you feel awe at the vastness of space, that is space feeling awe at itself. Every time you ask questions about origins and meaning, that is existence questioning its own nature. This realization transforms the question of whether we are alone. Even if there are no other civilizations, we are not alone because we are not separate from the rest of existence. We are intimately connected to everything, to every star, every planet, every atom in the cosmos. We are family with all of it, made of the same substance, governed by the same laws, part of the same unfolding story. And if there are other civilizations, other forms of consciousness scattered across the universe, then we are connected to them too. Not through communication or contact necessarily, but through shared origin, shared substance, shared participation in the cosmic journey from simplicity to complexity, from unconsciousness to awareness. Every living thing on Earth is part of this connection. The tree outside your window, the bacteria in your gut, the birds singing at dawn, all of us are part of the same family tree, descended from the same origin of life billions of years ago, and before that we are all part of the same atomic family, descended from the same stars. This perspective offers a different kind of comfort than the hope of finding alien life. It says, you are already connected to everything. You already belong to something vast and meaningful. Your existence is not an accident or an isolated event, but an integral part of the cosmos's development. When we search for life elsewhere, we are in a sense searching for ourselves, for other expressions of the same universal principles that created us. If we find microbial life on Mars, we will be finding cousins, beings whose existence parallels ours, whose chemistry might be the same or similar, whose origin might teach us about our own. If we find intelligent life on a distant world, we will be finding mirrors, consciousnesses that reflect our own capacity for awareness and wonder. But whether we find them or not, the connection is already there, woven into the fabric of reality itself. We are all expressions of the same universal laws, all participants in the same cosmic story, all temporary configurations of matter and energy that will eventually disperse and reconfigure into new forms. This is not a sad or nihilistic thought. It is liberating. It means your existence is not meaningless just because it is temporary. You are part of something eternal, not as an individual, but as a manifestation of the universe's ongoing creativity, its endless experimentation with what is possible. Every moment of joy you experience is the universe experiencing joy. Every connection you make with another person is the universe connecting with itself. Every act of kindness, every creation of beauty, every moment of understanding, these are all the cosmos expressing itself through you, exploring its own potential. This is the deepest meaning of the search for extraterrestrial life, not finding others, but recognizing our connection to everything, not discovering aliens, but understanding that there is no alien because everything is part of the same whole. Differences exist, certainly vast and wonderful differences, but beneath those differences is unity, shared origin, shared substance, shared fate. As you rest here now, feel that connection. You are not an isolated island of consciousness floating in an empty void. You are a wave in the ocean of existence, temporarily distinct but never separate, arising from the whole and eventually returning to it. Your awareness is the universe's awareness. Your wonder is cosmic wonder. Your search for meaning is existence searching for itself. This realization does not answer all questions or solve all problems, but it provides a foundation, a sense of belonging that transcends the particulars of whether we are alone in the universe. We belong to the universe itself. We are home because we are part of home, not visitors but native expressions of cosmic possibility. And perhaps that is what we are really seeking when we search for extraterrestrial life. Not aliens to converse with, but confirmation of this connection, evidence that consciousness is not a fluke but a natural expression of the universe's nature. We want to know that awareness is woven into the fabric of reality, that we are not accidents but inevitable consequences of the universe's capacity for self-organization and self-reflection. Whether we find that confirmation or not, the connection remains. You are stardust. You are consciousness. You are the cosmos, experiencing itself. And in that you are never truly alone, because you are part of everything. Final reflection, a peaceful ending. The night is quiet now. You have journeyed far, through time and space, through possibility and wonder. You have contemplated stars being born and civilizations rising and falling. You have considered microbes on distant worlds and the silence of the cosmos. You have looked inward and outward, asking questions that have no easy answers. And now, as we come to rest, let us simply be present with the mystery. There is no urgency to solve it, no pressure to know for certain. The universe has been here for billions of years, and it will continue for billions more. In this moment, we can simply exist within that vastness, feeling both our smallness and our significance. Maybe, one day, we will hear a voice calling across the light years. Maybe tomorrow, or next year, or in a century, a signal will reach Earth that cannot be explained by any natural process, that can only mean one thing: someone else is out there. In that moment, everything will change. The loneliness of our existence will lift, replaced by the excitement of connection, the anticipation of learning, the profound relief of knowing we are not alone. Or maybe we already have heard such a signal, but did not recognize it. Maybe we are surrounded by messages we have not yet learned to decode, by signs we have not yet learned to interpret. Maybe alien life is not rare, but simply different enough that our tools and our minds have not yet grasped how to perceive it. Or maybe we are alone, at least for now, at least in this corner of the galaxy, at least in this moment of cosmic time. Maybe life is rare and precious and fragile, and we are one of the few places where it has taken root and flourished. If so, the responsibility is profound, and the meaning of our existence is amplified by its rarity. Until then, we continue our journey, not just across space, but within ourselves, searching for the answers in the stars and in our hearts. We look outward with our telescopes and spacecraft, pushing the boundaries of what we can observe and explore, and we look inward with our philosophy and art and contemplation, exploring the nature of consciousness, meaning and connection. Both journeys are essential. Both transform us. Both remind us that we are part of something larger than ourselves, whether that is a galaxy full of civilizations or a cosmos where consciousness has emerged in at least one beautiful, miraculous place. As you drift towards sleep now, let yourself feel the wonder of simply existing. You are here, aware, capable of contemplating the infinite. You are made of ancient materials, organized into a form that can question its own existence. You are temporary, like everything else, but in your brief moment of existence, you have the capacity to love, to create, to understand, to connect. The stars above continue their slow wheel across the sky. The universe continues its expansion, cooling and organizing, creating new possibilities even as old ones fade. Life continues its evolutionary journey, exploring the space of what is possible, sometimes flourishing, sometimes failing, but always persevering, always reaching toward complexity and awareness. And you're part of all of it, not separate, not alone, but woven into the very fabric of existence. Your thoughts are the universe thinking. Your wonder is cosmic wonder. Your search for meaning is part of the cosmos's ongoing exploration of its own nature. Perhaps we will one day make contact with another civilization. Perhaps we will hear their story and share ours. Perhaps we will learn that consciousness is common, that awareness arises naturally wherever conditions permit. Or perhaps we will learn that we are unique, that our particular expression of cosmic possibility has happened only here, only now, only in us. Either way, we are profound. Either way, we matter. Either way, our existence is a miracle worth celebrating, preserving, cherishing. So rest now, knowing that you are part of something vast and beautiful. You are stardust and consciousness, matter and meaning, temporary and eternal all at once. You are the universe experiencing itself, and in that experience, you are exactly where you belong. The search for extraterrestrial life continues. Patient and persistent, the telescopes listen. The spacecraft explore. The scientists analyze. The dreamers dream. And somewhere, perhaps, another consciousness does the same, looking up at their sky, wondering about us, hoping as we hope that connection is possible across the vast distances that separate us. For now, let the mystery remain. Let the question hang in the cosmic silence, unanswered but not unanswerable. Let yourself drift in the space between knowing and not knowing, between solitude and connection, between the finite and the infinite. You are here, you are aware, you are part of the cosmos's journey toward understanding itself. And that, regardless of what else may exist in the universe, is enough. It is more than enough. It is everything. Sleep well, traveler. Dream of stars and worlds beyond imagining, and know that whether we are alone or part of a vast cosmic community, we are exactly where we need to be, exactly who we need to be, exactly when we need to be. The universe holds you in its embrace. You are home. In the quiet spaces between stars, in the patient waiting of radio telescopes, in the dreams of those who wonder about life beyond Earth, the search continues. And in continuing, it transforms us, reminding us that the most profound discoveries are not just about what we find out there, but about what we find within ourselves. Rest now, wonder, dream, and know that you are part of the greatest mystery and the greatest miracle the universe has ever produced. Life, consciousness, awareness reaching out across the void, seeking connection, seeking understanding, seeking to know if somewhere someone else is doing the same. Good night, child of Earth. Good night, child of stars. Good night, consciousness exploring itself through you. May your dreams be filled with wonder, and may the morning bring new possibilities for discovery, connection, and understanding. The journey continues, always,